Hello everyone, welcome to the session. How are you guys? So my dear friend, today we are going to start the Maha revision of digital electronics, right? And this is a part 1. So basically we are going to cover the number system and some other portion of the digital electronics in this particular session. So everyone, please do let me know into the comment box. Everything is fine, audio and video, so that we can start the session. Everyone. What is basically the syllabus of the number system? First, let me give you the brief idea about the syllabus and then we are going to start, right? For the electronics as well as for the electrical branch, the syllabus are basically the common, right? So, if we'll first discuss the syllabus, look at here. The first, this is called number system. In the number system for the ECE syllabus, if you'll observe, then in the number system it is given that the integer, floating point, right? That's point are basically mentioned, right? Fraction, integer and floating point. And so this is basically the number system only, right? So entire portion, whatever we can say that if you go into the very much of the detail regarding to the integer, floating point and the fraction part, then we can say that there are the two types of the question we can or not two, actually the three type of question we can expect into the number system. First, related to the base conversion. If any base is basically given, how we are going to convert into some other base, that is the first type of question. Second type of the question related to the magnitude representation. If any numbers are basically given, how you are going to represent those number into the some you can say that into the some other way, like how we are going to represent if binary number system is there, then how we are going to represent into the base, you can say that into the unsigned representation, signed representation, 1's complement form, 2's complement form. That is the type 2 question we can expect into the number system. Third type of question we can expect into the number system is like arithmetical operations, right? Some addition, subtraction, right? Multiplication, like these type of question we can expect into the number system. So the first portion is called number system. The second, after that you have to start, that is called, yes. After the number system, we have to discuss about the logic gate. And if you guys are basically ready, then I will discuss about the sequential circuit first, right? Okay, because this is a very important, right? So number system, logic gate. In the logic gate, NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR gate, XNOR gate, that portion we have to cover. Third one is called, after the logic gate, the third one is called minimization. In the minimization, my dear friend, there are two tools. The one is called Boolean algebra . Actually, there are three tools. One is called Boolean algebra, second one is called Karnaugh map, third one is called tabulation method, Quinn-Mescalski method also, right? But generally in our syllabus, Boolean algebra or K-map we have to discuss, right? So Boolean algebra and K-map. Fourth point, if you want to discuss, so number system, logic gate, minimization. After that, we have to start the combinational circuit. After that, we have to start the combinational circuit. In the combinational circuit, a circuit which does not contain any memory, right? Without memory, a circuit are called nothing, it is just a combinational circuit. So if you apply the input, you will get the output. If you remove the input, the output is also going to be removed, right? Right, okay. Good morning, dear. How are you, beta? So this is called nothing, it is just a combinational circuit, right? So in the combinational circuit, we are going to discuss about the comparator, mux, demux, encoder, decoder, half adder, full adder, half subtractor, full subtractor, those portions, right? Fifth one, we can say that after the combination circuit, we will start the sequential circuit. So after that, we will start the sequential circuit. In the sequential circuit, a circuit with the memory are called nothing, it is just a sequential circuit. So sequential circuit, we can say that latches, flip-flops, registers and counters. These four parts we are going to discuss about the sequential circuit, right? So let me write it also. That is called latches, flip-flops registers and counters. So latches, flip-flops, registers and counters. These 4 topics we are going to cover in the sequential circuit, right? Okay, now, just after that, my dear friend, next after the sequential circuit, we are going to discuss the 6th one, and that is called machine cycle. Or actually we can say that finite state machine, FSM. FSM finite state machine. There are 2 parts of the FSM. One is called Mealy and the second one is called Moody FSM. These part also we are going to cover. So one is called Mealy FSM, Mealy finite state machine, and the second part is called Moody FSM. Actually, for the CS student, generally we are not dealing this topic because this topic is already in very much of detail in the TOC subject, theory of competition. But for the electronics point of view, we have to discuss the finite state machine also, FSM, right? Okay. Just after the FSM, the next part is called, we have to discuss about the memories, right? So memory is also in the syllabus of the EC student. In the memory, we can classify the memory into the 2 parts. One is called mainly RAM and ROM. So in our syllabus, the RAM is there, right? So RAM we have to split into the 2 parts. One is called static RAM and the second one is called dynamic RAM. Static RAM is also classified into the 2 further 2 portion. One is called 40 model and the second one is called 60 model. So the memory also we are going to discuss in very much of detail. And just after that, the 8th point, that is called setup time and hold time, especially mentioned into the syllabus, setup time and hold time. Let me write into the next chapter, next slide, right? Okay. Next 8th portion is called nothing, it is just a setup time and hold time. So not only the setup time and hold time, what should be the meaning of contamination delay? What should be the setup time? How we can apply into the flip-flops, right? So setup time, hold time, what should be the condition for that? When the setup time violation is happening, when the hold time violation is going to be happen, how the designer is going to introduce the buffer into that. So everything regarding to the setup time and hold time, what should be the, how we are going to decide the frequency on the circuits. So these part also we are going to cover in the this topic, right? 9th point is related to, that is part of the that is MOS implementation, a logic gate, or we can write CMOS implementation. CMOS implementation of functions. Now everyone try to understand, not only the CMOS implementation, we are going to discuss about the that is NMOS, how we are going to design any of the function by NMOS, PMOS, CMOS. Earlier there are the one chapter, there is the one chapter that is called logic family, which is in syllabus. In the logic family, we have to discuss about how the logic gates are basically designed, like RTL, register transistor logic, DCTL, direct coupled transistor logic, HTL, high threshold logic, right? I2L, HTL, after that TTL, right? ECL, emitter coupled logic. So there are several type of the logic family members are basically there. In those particular things, the one is called NMOS, PMOS and CMOS implementation also. So all the topics are basically removed, but still the CMOS implementation are still into the syllabus. So we have to cover these things also, right? Okay. Just after that, there will the one thing more we have to discuss, and I think this is the syllabus is sufficient, right? Okay, setup time, hold time, CMOS implementation. These are the basically the topic which we are going to discuss, right? Okay. So let's start, guys. The first, let me discuss about the number system. So in the 2 days, we are going to discuss about the number system and mainly the sequential circuit. These topic we are going to cover, right? Right. Okay. So let's start with the first, number system. In the number system, first, if I will discuss about the base, what should be the meaning of base? Everyone try to understand. If, all right, okay. So if I will discuss about the base, either we can use the word base or we can use the word radix. Both are basically the same. The base means the total number of digits used into the system are called nothing, it is just a base, right? Code converter is also there. So code converter is the part of the combinational circuits, right? So we are going to discuss into the combinational circuit only, right? Okay. So the total number of digit present, suppose if any number system is there, and if we are talking about the decimal number system, in the decimal number system, base is called 10 and the number of digit present is from 0 to 9. So 0 to 9, how many digits are there? Total 10 digits are there, right? Okay. Now if I will discuss about the binary number system, in the binary number system, the total base is 2 and the digit present is 0 and 1. That is the total digit is 2. Octal number system, if I will discuss about, then the base is called 8 and the digit present is 0 to 7. If I will discuss about the hexadecimal number system, then we can say that the base is called 16 and digit is from 0 to 9, and 10 we can represent like A, 11 as a B, C, right, 12 like that, and 15 as a F. So 0 to 9 and A to F, these digits are present. Now everyone try to understand and give me the answer. If I will ask 1 to C, can anybody give me an answer? What should be the base of this particular number system? Can anybody give me an answer? What should be the base of this number system? Everyone please respond and give me the base of this number system, 1 to C. Nobody is responding, okay. If for the 1 to C, if I want to discuss about the base of the number system, everyone try to understand. We are not able to comment at this particular point what should be the base of this number system, right? How we can say that? Oh, EDC or DAC, yes, one thing I have missed, right? That is the 10th point. That's why I thought, right? ADC and DAC. Definitely one question we can expect from here, right? Analog to digital and digital to analog converter. Yes, definitely, right? So one question definitely we can expect from here, that is ADC and DAC. This topic I have skipped, right? But yes, we are going to cover this topic also, right? ADC and DAC. Now everyone try to understand. People has responded, right? The base is 16. No, we cannot directly comment the what is the base of this number system, because if you observe into the number system, suppose if I have given the base is called 2, then the digit present is 0 and 1. Base is 3, 0, 1, 2. Base is 4, then 0, 1, 2, 3. So whatever the base is there, you can start the number from 0, 1, 2 and whatever, suppose base is called R. So the digit present up to R minus 1, right? You can feel if the base is 4, so up to 3 number is present. You can never observe if the any number system having the base 4 and on those particular number system the 4 is also present as a digit. No, it's not possible, right? No issues, Harshit, how are you? Okay, yes, right, okay. It is in the mixed form, right? General conversation is going to happen into the Hindi. Otherwise, all the technical concept will deliver in English, right? Okay, now, suppose if the base is called 6. So everyone try to understand. If base is basically 6, then up to 5 you can feel 0, 1, 2, 3, 4, 5 digit present. If I can write the base is called 8, that is called octal number system. So in the octal number system, we can say that 0 to 7 digits are present. So you never feel that 7, 8, 3 and 8 are present. No, it's wrong. Why we can say that? If the digit is 8, then base must be 1 greater than that digit. Maybe 9, maybe 10, maybe 11, anything. But 8 we cannot put, right? Okay. So everyone, whenever I will discuss about the decimal number system, the digit presents are basically total number of 10 digits are present. Yes, absolutely correct, Jay. Now, if 11, if I will discuss, then 0 to 9 and A, 12, 0 to 9 AB, 13, 0 to 9 ABC, 14, 0 to 9 ABCD, 15, 0 to 9 ABCDE, 16, that is hexadecimal 0 to 9 ABCDEF, right? Now everyone try to understand. I have asked the question 1 to C and what should be the base of this system. So whether the C is present only into the hexadecimal? No, it's not present only into the hexadecimal. C is present into this system also, this also, this also, this also. So in the 13, 14, 15, 16, everywhere the C is present. In the similar manner, if I will ask the question, what should be the meaning of 101? We are not able to comment. You can note whether it is only the binary number system. No, 1 and 0 is present into the every number system. So maybe it's a base 2, 3, anything is possible. Yes, if I will discuss about what should be the minimum base system, then you can say that the minimum base system is called 2. Otherwise, anything is possible. In the similar manner, if 1 to C is there, directly we are not able to comment what should be the base of this system, right? You have to observe, okay, 1 to C is there. C means what? Look at here. C's minimum is present at the base 13. So we can say that the base is called 13, 14, 15, anything, right? 16. But yes, but in the question, if they will talk about what should be the minimum base, then you can give the answer. The minimum base is called 13. Minimum base is called nothing, it is just a 13. So hope you guys understood this one, right? Okay. Now, if the minimum base is called 13, now everyone just already have discussed there are two parts of this particular syllabus, right? One is called in the base conversion. Two topics are very important, right? The one is called any base to decimal conversion. Yes, definitely there are some shortcut also which we are going to discuss. And the second part is called decimal to any other base conversion. So two topics is very important. One is called how we are going to convert the any base into the corresponding decimal. Any base is, So any base is basically given, you have to convert into the decimal. And the second part is called if decimal is given, how we are going to convert into the some any other base. So this topic is very, very, very important, guys, right? One doubt, why generally base of the number system is discussing up to hexadecimal? No, it's not up to hexadecimal only, right? We are discussing because in the computer, the mostly the codes and what we are going to write into the hexadecimal only, right? Whenever you write in assembled language, right? That's why we are discussing up to the hexadecimal only. That's why we are using the hexadecimal, but it's not necessary. Okay. I will, if time allowed, then we'll discuss the how the base are basically decided and what should be the meaning of that, right? Okay. So this is a crash course actually. This is not a actual course. That's why I'm little bit you can say that the fast we are moving. Okay. Now, whenever the any base to decimal conversion, if I will discuss, everyone try to understand. Whenever the any base to decimal conversion is given, suppose the number is basically given like A3, A2, A1, A0, point A minus 1, A minus 2 in base R, and you want to convert into the base 10, right? Okay. How we are going to do? Every number system having the weight and their coefficient. So this A3, A2, A1, A0 and A minus 1, A minus 2 are basically called nothing, it is just a coefficient, right? And if base is R, so coefficient will be 0, 1, 2, 3 up to R minus 1, right? Okay. Now, what should be the base of, suppose if you have given the any, if you have given the, as a loan, if you have given 501 to the any of the people, right? Okay, yes. So you are from Raurkela. Okay, so suppose if 501 in the decimal, if you have given as a loan to 501 to the any of your friend, and now it's time to return back, what you will say? Ki give me 500 rupees, forget about 1 rupees, or give me 1 rupees or forget about the 500 rupees. No, you will say that okay, give me 500 rupees and forget about the 1 rupees. How we can say that? Because if it is a decimal number system, every digit having the some weight into the 10 raised to power. So 5 having the weight 10 raised to power 2, 0 having the weight 10 raised to power 1, 1 having the weight 10 raised to power 0. So the lowest weight is called for the 1, right? And the highest weight is for the 5. So 5 is essentially required. That's why a digit or coefficient which having the highest weight or maximum weight are called MSB, most significant weight. And a coefficient which having the least weight are called least significant weight, right? Okay. So in the similar manner, if A3, A2, A1, why we are taking the base right in the power of the 10? Because here the base is called 10, right? So here we can say that if base is called R, so the power is called R raised to power 0, weight R raised to power 1, R raised to power 2, R raised to power 3. Here we can say that R raised to power minus 1, R raised to power minus 2. And now we have to multiply their coefficient with their base. So their coefficient. So the coefficient is multiplied with the weight. So we can say that A3 into R raised to power 3 plus A2 into R raised to power 2 plus A1 into R raised to power 1 plus R0 into A0 into R raised to power 0 plus A minus 1 into R raised to power minus 1 plus A minus 2 into R raised to power minus 2, and yes, you have converted into the decimal. It's very simple. So if you want to convert the any number system into the corresponding their decimal number system, always you have to do the one thing. Multiply their coefficient with their weight. That's it. Nothing more than that. Okay. Now suppose 1011.11 base 2 is given and you want to convert into the base 10. How we are going to given, right? How we are going to do it? Sir, this is the base 2 is given. So every position having their coefficient, this is the coefficient, and every coefficient having their weight. Suppose before the decimal 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power minus 1, 2 raised to power minus 2. That's it. So we have to multiply their coefficient with their weight, and that's it, right? You have converted into the decimal. So if you'll do it, we can say that this is called, already I have given the idea, this is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power minus 1, and 2 raised to power minus 2. So 1 into 2 raised to power 3 plus 0 into 2 raised to power 2 plus 1 into 2 raised to power 1 plus 1 into 2 raised to power 0 plus 1 into 2 raised to power minus 1 plus 1 into 2 raised to power minus 2. We have done like this, right? Okay. And now we have added, so the number is called nothing, 11.75 is the answer of this question. 11.75 is the answer of this question. It's very simple. It's not that much of difficult, right? Isn't it? If you have solved this question, let me give you one more question. Everyone just give me an answer. So whenever you want to convert the any base into the corresponding decimal, always you have to multiply their weight with the coefficient. That's it. So if you want to do it, it is called r raised to power 0, r raised to power 1, r raised to power 2, r raised to power minus 1, r raised to power minus 2. So if you multiply 4 into, so this is called, r is called 5. So we can say that this is 5 raised to power 0, minus 1, minus 2, 1 and 2. So 4 into 5 raised to power 2 plus 3 into 5 raised to power 1 plus 2 into 5 raised to power 0 plus 2 into 5 raised to power minus 1 plus 2 into 5 raised to power minus 2. And you will get the answer. Alright. So everyone, if you will do like this, everyone, what should be the answer of this? 117.48. That's the answer of this question. Alright. So only the coefficient and their weight must be multiplied and added. That's the answer of this, right? Okay, now. Suppose one more question I am giving you, everyone. Just give me the answer of this, and hope you guys can solve this also. Suppose I am giving you 375.4 base 8. And I am talking about convert into the decimal. Can you do it for me, everyone? It's very simple, right? How you can convert it? So we have to multiply their weight with their coefficients, right? So there the weight is called nothing, it is just 8 raised to power minus 1, 8 raised to power 0, 8 raised to power 1, 8 raised to power 2. So 3 into 8 raised to power 2 plus 7 into 8 raised to power 1 plus 5 into 8 raised to power 0 plus 4 into 8 raised to power 4 into 8 raised to power 1 in the decimal. You can add it, you will get the answer. It's very simple, right? Okay, now let's discuss the second part of it. Second part means what? If any decimal number system is given, if any decimal is basically given and you want to convert into the some other base. So the meaning of this one is decimal number system is given and you want to convert into the some other base. I don't have any idea about the base at this particular moment. So I can say that suppose the base R you want to convert. So if any number system, suppose A3, A2, A1, A0, A3, A2, A1, A0, point A minus 1, A minus 2, A minus 3 is basically given, right? So this is given A3, A2, A1, A0, point A minus 1, A minus 2, A minus 3 is basically given, right? Okay, now the question arises, it is into the base 10. How we are going to convert into the base R? That's the question is there, right? Okay. So if you want to convert it, you have to split the number into the two part. One is called before the decimal and the second one is called after the decimal. So before the decimal and after the decimal, you have to classify the signal numbers into the two part. So I can take the before the decimal is called A3, A2, A1, A0, and after the decimal the number is A minus 1, A minus 2, A minus 3. So before the decimal number system must be divided by R and you have to take the remainder. And whatever the remainder is there, you have to take into the down to up direction. You have to select into the down. So you can write A3, A2, A1, A0 into the base 10, convert into the base R like B3, B2, B1, B0, right? So downward to upward direction you have to write. Okay. Now after the decimal, whatever value is there, suppose it is given 0.A minus 1, A minus 2, A minus 3, you have to multiply by R. So if you multiply by R, you will get suppose X0, point X minus 1, X minus 2 you will get. So select X0. Now this again 0.X minus 1, X minus 2 is there, again multiply by R. Suppose you are getting X1, point X minus 3, X minus 4. Choose the X1. Now remaining the 0.6 X minus 3, X minus 4. So you can put 0.X minus 3, X minus 4 multiply by R. You will get X2 point X minus 5, X minus 6. Again you can take, that is called X2. And invert in this direction, you can take from top to bottom direction. So the complete conversion is called B3, B2, B1. You can feel this is B3, B2, B1. B3, B2, B1, B naught point x minus 1, x naught, x1, x2. So before the decimal, remainder should be into the bottom to top direction. And after the, or you can say that after remainder where you can multiply with the R, you have to choose top to bottom direction. That's the important thing, right? Okay. How we are going to do it? So let's take the one example. By the example, we can understand it. So if I'm asking the question, everyone, try to understand. If I will ask the question, a very simple question. Suppose 19.75 base 10 is given and you have to convert into the base 2. How we are going to do it? So if we want to convert into the base 2, it's very simple, right? How we are going to do it? We have to take the two numbers are basically there. So before the decimal, after decimal, we have to split those numbers, right? So first I will take the 19 and divide the 19, in which base you have to convert the 2, and remainder you have to write here. So if you will divide the 19 by 2, it will go 9 times and the remainder will become 1. Now again 9 we have to divide the 2 times, so it will goes on to the 4 times and remainder is 1. Now 4 we can divide into the 2. So how many times? 2 times, and the remainder is 0. Again 2 we have to divide with the 2. So the remainder is going to be 0 and it will go 1 times, and 1 we have to write. And here already I have discussed, we have to choose from bottom to top. Just write from 0 to 7, 0.75 number system is basically given. You have to multiply by whatever the digit in the base you have to convert. So we have to convert into the base 2. So 0.75 we have to convert into the base 2, right? Yes, absolutely correct. So 0.75 into 2, so it will happen 1.5. Now you have to choose this one and write here. Now it will become 0.5, 0.5 into 2. So it will become 1.0, and now 1 you have to choose, and this is called like this. So the conversion of 19.75 into the base 10 into binary is called 1, 0, 0, 1, 1.11 into base 2. This is the right. This is the answer. Very simple, right? Okay. Hope you guys understood. If you have understood, solve this question and give me the answer. Everyone, just solve this question and give me the answer of this. One, 228.55 into the base 10, and you have to convert into the base 16. Everyone, just give me the answer of this question. So 1228.55 into the base 10. If you want to convert to the base 16, there are two. You have to split this number into the two parts, before the decimal and after that. दो part में आपको तोड़ना होगा. Before the decimal and after the decimal. So before the decimal it's 1228, and you have to divide by the 16. And 0.55 is there. You have to multiply by 16. So you have to do like this, right? Okay, everyone. So if you divide, it will be happen like 1228 divide by 16. How many times it will be go? All right. Okay. So if you divide 16, if you divide 16 to this particular number, so it will go 76 times, and the remainder will become nothing, it is just a 12. So A we can write as a 10, B we can write as a 11, C we can write as a 12. So 12 is basically written as a C, because we have to convert into the hexadecimal, right? Okay, that's why we are dividing by 16. Now 76 is there. Again 76 is divided by 16. So 76 if you divide by 16, it will go 4 times, and the remainder again will become 12. So 12 we can represent as a C. So we can write as a C, right? And now in the last 4, so we can write 4. In this way, we have to write into the bottom to top direction. So the conversion of 1228 base 10 into the base 16 is 4cc. In the similar manner, suppose 0.55 we have to multiply by 8. So 0.55 multiply by 16, sorry, not 8, by multiply by 16, so it will become 8.8. Now we have to choose the 8. Now it will become 0.8. So 0.8 again multiply by 16. So it will become 12.8. So 12 again we can write C. Now you have to choose 8. So 0.8 again multiply by 16. So again you will get 12.8. So C it is going to happen. So the conversion of 1228.55 into the base 10 into the base 16 is 4cc.8c into the base 16. That's the answer of it. Right? Okay. Hope you guys understood. If you have understood this point, let me give you the one more question so that, or otherwise it's very simple, right? How we are going to convert into the base 16. So two portion we have discussed till now. If any base is basically given, how we are going to convert into the base 10, and if base 10 is basically given, how we are going to convert into the base R. Now my question is, suppose if I'm asking the one question, and that question is 432, suppose I'm giving you into the base 5 and I'm asking convert into the base 4, everyone. Now we know that, sir, how we are going to convert the base x into base 10 or base 10 into the base y, but we do not have any idea about how directly we can convert the base 5 into the base 4 or any other base x into the base y. So we can use the intermediate base, right? Suppose 4321, if into the 10, then also the similar. Suppose we have to take intermediate as a 10. So we know that how we are going to convert the base 5 into the base 10, and we know that how we are going to convert the base 10 into the some other base, right? So it will become very easy. So we have to convert the base 5 into the base 10 and then base 10 into the base 4. That's what you have to do, right? So doubt है डिकोडर के बारे में पूछ सकता हूँ. हाँ, सो हम पूछ सकते हो, बट अभी टॉपिक से डेविएट हो जाएंगे हम. अभी नंबर सिस्टम पहले देखते हैं. डिकोडर भी आएगा, डिकोडर के टाइम में आप डिकोडर का पूछ लेना, कोई दिक्कत है, मैं आपको एक्सप्लेन भी कर दूंगा, डोंट वरी. So how we are going to do, everyone? 432 base 5 is given 4. So if you want to solve it, it's very simple. We can write like, suppose the first part is called 432 and we have to convert into the base 10. So if you want to convert into the base 10, we have to multiply their weight with their coefficient. So this is a coefficient and their weight is called 5 raised to power 0, 5 raised to power 1, 5 raised to power 2. So it's called 4 into 5 raised to power 2 plus 3 into 5 plus 2 into 5 raised to power 0, and it's into the decimal. So if you want to convert it, it's very simple again, right? What should be the value? 25 into 4, that is called 100. 100 plus 15, 15 plus 2, so 117. Right, 117. Okay, now 117 we have to convert it to the base 4. So 117 is there, 117. And if you want to convert into the base 117, if you want to convert into the base 4, so we have to divide it, right? We know that how any number we have to convert into the base, you can say that the 4 decimal number. So if you will divide by 15, how many times? How many times it will go? Can anybody give me an answer? Can you, now you know that how we are going to convert it, right? Everyone, just do it and give me an answer. How many times? 32 times it will go, right? And 32, 4 ja, if you want to write, what should be the value? 128. So what should be the remainder you will get? 128. 130, no, just give me. 117 is there, na? 29. 29 times it will go, right? On 116, so the remainder 116, so remainder is called 1. Now again you have to divide by 4. So how many times? 4 if you want to divide. 7 times. Remainder will become 1. Now for 1 times, remainder will become 3, and this is called 1. So 1311. 1311 is the answer, right? 3211 क्या लिख रहे हैं? 1311. So one people has given the correct answer. 2. भाई इतना पढ़ाने के बाद यहाँ गलती करोगे तो कैसे काम चलेगा? So 432 base 5 converted into the base 1311 into the base 4. That's the answer of this. ज़्यादा बड़ा नंबर हो गया यार. 29 को किया, ठीक है. Yes. So hope you guys understood how we are going to do it, right? Okay. So one thing more you can understand, everyone try to understand, right? If you have understood this point, let's move into the next part. Suppose this number system, everyone try to understand how the any number systems are basically. One other approach is there. But before going to that, let me give you the one few parts of this particular steps, right? Or another things. Some special cases are also there. Special cases are also there. Special case means what? Everyone try to understand. Suppose if I am giving you 1 0 1 1 0 1 0 and this is in the binary, and if I am talking about convert into the base 8, how we are going to convert? So one method is called, that is the normal method, everybody we can do. They can convert the base 2 into the base 10 and then base 10 into the base 8. That's very easy. But the one thing is also, if both in this side and in this side, if both are basically having the some common base, a common, you can say that the base in which in the power of the values you can write. Suppose this 2 we can write as a 2 raised to power 1 and this 8 we can write into as a 2 raised to power 3. So we can say that intermediate you can use as a 2 also. Here we can say that if we'll select for the binary, group of the 3 digit of the binary will represent the 1 digit of the 8, right, base 8. So we can say that the meaning of this one is called 3 digit of binary will represent one digit of base 8. So we can say that the 3 digit of the binary will represent the 1 digit of base 8, or we can say that 1 digit of base 8 can be represented as a 3 bits of the binary. So if you want to represent like this, we can say that, everyone try to understand in this particular question, we have to take the group of 3 bits, right? So if I am taking the group of 3 bits, if it is not there, so we can make the 0 into the MSB. So this is called 1, this is called 3, this is called 2. So conversion of this one is called 132 into the base 8. That is the answer of this. Directly we have done this like this. Suppose if I am asking the one more question, and that the question is like 1 1 0 1 1 1 0 1 0 1 1. Suppose this is a binary and we are talking about convert into the base 16. So now again you can feel the both are basically having the some common thing, common base, that is called 2. Because this 2 we can write as a 2 raised to power 1. This one we can write as a 2 raised to power 4. So we can say that the 4 digit of the binary will represent the 1 digit of the hexadecimal. So we have to take the group of 4 bits, right? So by the binary also you can take as intermediate, directly conversion is going to happen. 4 1 2 3 4. So we can say that this is a 4. 1 2 3 4. So we can see that 4. 1 2 3 and 1 digit is missing, so we can write like this. 0 1 1 0. So this is called 6. 1 8 12 14. So this is called 14. 8 to 10 and 11. So it is called 11. A means 10, B means 11. So this is called B. C means 12. D means 13. E means 14. So this is called 14. So the conversion of this one is called 6E B into the hexadecimal. That is the answer of this question. Maybe there will be the typing error, but the approach is the similar, right? Everyone, write down yes or no, understood? Everyone write down yes or no, understood this point? 6EB, yes, correct. Suppose if I am asking one question and that question is like 7354 in base 8 and I am asking convert into the base 16. So again you can feel, everyone try to understand. If you want to convert it, we can say that both having the some common base also. right? This is called 2 raised to power 3 and this is called 2 raised to power 4. So binary is the common between those things. So directly either we have a two approach. One, we can convert this octal into the decimal and then decimal into the hexadecimal, we know that. And the second approach is called, you can take the intermediate as a binary number system. So if I will take the intermediate as a binary number system, it will become very simple. How we are going to do it, everyone? Here we can write like, if in the binary number system, how we are going to convert the octal into the binary number system? Sir, every digit of the octal must be represented by the 3 bit of the binary. So we can represent the 3 bit of the binary of this. So 4 we can represent like 100, 5 we can represent like 101, 3 we can represent like 011, 7 we can represent like 1. This is a binary. So every number system, every octal number is represented by the 3 bits of the binary. Now binary, we know that. How we are going to convert the binary into the hexadecimal? We have to take the group of 4, right? So we can say that we have to take the group of 4. So this is a group of 4. 1, 2, 3, 4, 4, 1, 2, 3, 4. So this is called 14. This is also 14. This is called 12. A means 10, B means 11, C means 12. And this is called E. 14 means E. So this is called E, E, C into 16. This is the answer of this question. E, C is the answer of this question. Suppose if I am asking one more question, if you have understood this point, let me give you one more question so that you can correlate it, everyone. If I am giving you the one question like 2, 3, 2, 1, 2, 3, 3, 3 नहीं लिखता हूँ, 2, 1, 0, 2, 1, 1, 0, 2, 1, 1, 1, 2. This is into the base 3. This is in the base 3 and you have to convert into the base 9. Now can anybody give me an answer of this question? How can anybody give me an answer of this question? Right, everyone. So if you want to solve this question, everyone try to understand one thing very simple here. Base 3 and base 9 is basically there, right? So we can write, it is called 3. There is the one method is called, you have to convert it to the decimal. It's very simple, right? So base 3 we have to convert it to the decimal. And then decimal you have to convert it to the base 9. It will become very simple. And the second approach is what the shortcut approach I have discussed. Both having the some common base, that is called 3 raised to power 1 and this is called 3 raised to power 2. So anyhow, we can say that the meaning of this one is called, 2 digit of base 3 will represent one digit of base 9. So the 2 digit of the base 3 will represent the one. So we have to make the group of this. So we can say that this will become 1, 2. Then this will become 1, 1. Then this will become 2, 1. Oh, sorry. 0, 2. Then it will become again 1, 1. Then it will become 0, 2. Then it will become 2, 1. Now everyone, you have to understand what should be the meaning of this 2, 1, 0, 2, 1, 1 into the base 3 into the base 9, right? Or into the base 10. So everyone try to understand how the base 4 are basically represented. If you want to discuss about the base 4, how the base 4 digit are basically there, right? Base 4 digit we can write like a 0, 1, 2. And then it is going to be represented again, right? 0, 1, 2. And the next digit we have to use MSB as a 1. So it will become 1, 1, 1. Next digit is called again, this is 0, 1, 2. and next bit is called 2, 2, 2. Next, if you want to write 0, 1, 2, and next digit will be 1, 0, 1, 0 in the MSB, you have to add. Now, what should be the decimal equivalent of this? It is called base 3. If I want to write into the base 9, even base 10, if you want to discuss, this is called 0, this is called 1, this is called 2, this is called 3, this is called 4, this is called 5, this is called 6, this is called 7, this is called 8. So this will become 8 only, right? Up to that sequence only you can write, okay? So you can understand, everyone try to understand 1, 2. 1, 2 is 1, 2, 1, 2, 1, 2. 1, 2 is represented as a 5. Oh. So 1, 2 represented as a 5. 1, 1 if you want to discuss. Slider kahan gaya yaar? So 1, 1 we can represent as a 4. So we can write as a 4. 0, 2 if I will discuss. 0, 2, 0, 2, 0, 2, 0, 2. This is the 0, 2, right? So 0, 2 as a 0, 2 only. 1, 1 as a 4. 0, 2 as a 2. 2, 1 if I will discuss 2, 1. 2, 1 as a 7. So we have converted, right? That is called 7, 2, 4, 2, 4, 5 into base 9 is the answer of this question. So very simple. A people who has not understood this point, what should be the meaning of this? Everyone try to understand. You are writing, even though if you're writing the decimal number system also into the similar manner. Suppose if you want to write the decimal number system, how we are writing? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And next digit if you want to write, we have to take this one. This is a repetition of this, right? And after that you have to take the next bigger number as a 1 in the MSB. So pattern is object from 0 to 9 only. Next digit if you want to write again 0 to 9. And next you have to write as a 2 as a MSB you can use. Same thing in it. So 0, 1, 2, 3. It is not from 0 to 9. If base 3 is there, so 0, 1, 2 is there. So next number we can write repetitive form of 0, 1, 2. 0, 1, 2. 0, 1, 2. So next on 0, 1, 2 and what should be the MSB? So this one. 1, 1, 1. Now again the 0, 1, 2. What should be the next? 2, 2, 2, 2. Now again if you write 0, 1, 2. And next number is called MSB 1, 0. So we can write 1, 0, 1, 0, 1, 0 like this. Understood everyone? Write down yes or no. Everyone write down yes or no. Understood this point? Okay. Now everyone try to understand. One question is also there, right? How many ones are present in the binary representation of the number given below? 7 into 2 raised to power 4 plus 3 into 2 raised to power 1 plus 5. If this number is given, how many ones are basically present in this particular number if you convert into the corresponding binary? This number is given into the decimal, right? These 4, 7 all are basically this number is given into the decimal. So my question is, if you convert this decimal number system into the binary, what should be how many ones are basically present? Everyone. Now if you solve this question, everyone try to understand. There is a multiple way, directly you can also convert, but the one is called, whenever we will write any number into the 2 raised to power, suppose if I will write 2 raised to power, then we can say that this is called 1. If I will write 2 raised to power 1, we can say that this is into 1, 0. This is binary and this is decimal, suppose. Suppose if I will write 2 raised to power 2, this will become 1, 2, 0. 2 raised to power 3, 1, 3, 0. So if I will write 2 raised to power 5, suppose 1 and 5 times 0 we can write. So whenever we will write 2 raised to power n, if you want to represent into the binary, we can write 1, 0, 0, 0 n times 0. n times 0 we can write. Okay. So n times 0 we can write. Okay. Now, again we are coming into this question. So, first you have to write everything into the 2 raised to power. So, we can say that 7 we can write as a 4 plus 2 plus 1, and that will become 2 raised to power 4 plus 2 plus 1, and this will become 2 raised to power 1 plus 4 plus 1. This is in the decimal it is given, right? So, this is 2 raised to power 2 plus into 2 raised to power 4. So, it will become 2 raised to power 6 plus this is 2 raised to power 5 plus 2 raised to power 4 plus 2 raised to power 1, 2 raised to power 1. So, 2 raised to power 2, 2 raised to power 1. This is also 2 raised to power 2 plus 2 raised to power 0. Now, 2 raised to power 2, 2 raised to power 2. So, if you multiply, it will become 2 raised to power 3. Do not write 2 raised to power 4. Maybe sometimes the people are going to be confused, right? 2 raised to power 2, 2 raised to power 2, if you add, it never will become 2 raised to power 4, right? So, how we are going to do it? You can take the 2 raised to power 2 common, so it will become 1 plus 1. So, 2 raised to power 2 into 2 raised to power 1. So, it will become 2 raised to power 3, right? So, we can say that 2 raised to power 6 plus 2 raised to power 5 plus 2 raised to power 4. This will give you 2 raised to power 3 plus 2 raised to power 2 is 0, 2 raised to power 1 plus 2 raised to power 0. So, if you want to write now, look at 2 raised to power 2 is also there. So, we can say that the coefficient here it is 1, here it is 1, here it is 1, here it is 1, here it is 0. This is 1, this is 1. So, the conversion of this one, if you want to write, this is called 1, 1, 1, 1, 0, 1, 1 into base 2. So, how many ones are basically present if you want to convert 1, 2, 3, 4, 5, 6. So, answer is called nothing, it is just a 6. Otherwise, directly also you can write each term, this will also give you the one term. So, forget about this. 1, 2, 3, 4, 5, 6. 6 ones are basically present. Everyone write down yes or no, understood this point? Everyone write down yes or no, understood this point, yes or no? Okay, if you have understood this point, let's move into the next, right? Okay. So, suppose one more question is there. Can anybody give an answer of this question? The number of 1-bit representation in the binary representation of the decimal number 7 into 5 raised 512 plus 6 into 64 plus 5 into 8 plus 4 is m, and the number count 1 bit into the representation of this is n. You have to find the m plus n. Everyone just give me the answer of this question. Everyone just give me the answer of this question. So, we will solve this question. Everyone try to understand. First, there is a two method to solve this question, right? The method number 1 is called, let me write the method 1. And the method 1, if you want to solve, this is called 7 into plus 6 into 64 plus 5 into 8 plus 4. This is given, right? So, we can also write this is called 4 plus 2 plus 1. This is called 2 raised to power 9 plus 6 is called 4 plus 2. This is called 2 raised to power 6. 4 plus 1. This is called 2 raised to power 3 plus 2 raised to power 2. So, now if you want to write it, it is called 9 plus 2, so 11, 2 raised to power 11 plus 2 raised to power 10 plus 2 raised to power 9 plus 2 raised to power 8 plus 2 raised to power 7 plus 5, 3, 2 raised to power 2. This is the meaning of this. So 1, 2, 3, 4, 5, 6, 7, 8. So how many ones are basically present if you want to represent into the corresponding binary? 8 ones are basically present. That's the meaning of this, right? So m is called nothing, it is just a 8. Each term will give you the one into the binary, right? So m8. Now second part of this one is called nothing, it is just a 3 into 4096. Plus 2 into 256 plus 16 plus 1. So this one we can write 2 plus 1. 2 raised to power, this is called 12, right? Plus 2 into 2 raised to power 8 plus 2 raised to power 4 plus 2 raised to power 0. So 2 raised to power 13 plus 2 raised to power 12 plus 2 raised to power 9 plus 2 raised to power 4 plus 2 raised to power 0. Each term will give you the 1 corresponding to the binary. So 1, 2, 3, 4, 5. So n is called nothing, it is just a 5. 1, 2, 3, 4, 5. One thing more. 12, 13, 12. 8 or 9. Okay. 4 and 2 raised to, yes, 5. So m plus n is called 13. So 13, any option? No. So none of the correct, right? None is the answer of this particular question. This is the one method by which you can solve this question. There are method 2 also. Method 2. Same question if you want to solve, we have some different method also, that is called method 2. 7 into 512, 7 into 512 plus 6 into 64, 6 into 64 plus 5 into 8 plus 4. Now we can also observe this question like 7 into 8 raised to power 3 plus 6 into 8 raised to power 2 plus 5 into 8 raised to power 1 plus 4 into 8 raised to power 0. In the decimal, it is a representation. Now you can feel like it is 7, 6, 5, 4 into the base 8. So if you want to convert it to the decimal, it's looking like 7, dekho, 8 raised to power 0. So 4 into 8 raised to power 0, 5 into 8, 6 into 8 raised to power 2, 7 into 8 raised to power 3. So it is into the decimal. Now we can write into the binary like what? Every digit by the three bits of the binary. 6 we can write 1, 1, 0. 5 we can write 1, 0, 1. 4 we can write 1, 0, 0. That's it into the binary. So how many ones are present? 1, 2, 3, 4, 5, 6, 7, 8. M is called 8. So directly we can also write in this manner. Second one is called, everyone try to understand, this is called 3 into 4096. If you'll observe, 3 into 4096. 4096. 2 into 256. 2 into 250. 2 into 256 plus 16 plus 1 plus 16 plus 1. So if you'll observe, this is called 3 into 16 raised to power 3, 2 into 16 raised to power 2 plus 1 into 16 raised to power 1 plus 1 into 16 raised to power 0. So you can observe, this is a directly we can write into the 16 power also. This is into the decimal, right? So 3211 into hexadecimal. If you want to convert into the corresponding decimal, how we are going to write? 1 into 16 raised to power 0 plus 1 into 16 raised to power 1 plus 2 into 16 raised to power 2 plus 3 into 16 raised to power 3. So this is the meaning of this. Now if you want to write into the binary, how we can do it? Every digit must be represented by the 4-bit. So 0 means 0011, 2 means 0010, 1 means 0001, 0001 into the binary. So 1, 2, 3, 4, 5. So n equal to 5. That's the answer of this. Now 1 1 0 0, look at here, 1 1, we can say that if even though if you'll convert it, you can write it 1 1 13 12. Then 11 is 0, power 11 is 0, power 10 is 0. Now 9 is basically there. Now 8 7 6 5 is 0, 4 is there. Then 3 2 1 is 0 0 this. So this is the conversion only, we can see that. The similar 1 3 times 0 1. So 1 3 times 0 1, you can feel 1 3 times 0 1. So similar manner you will get. Everyone understood? Any of the one method you can use whatever the suitable for you, right? Both are basically the correct. So hope you guys understood how we are going to convert the any base into the corresponding binary, my dear friend. If you have understood this point, let's move into the some other part, and that is called how the magnitude is going to be represented. So everyone, whenever first we are discussing about the binary number system, then into the some other way, right? Right. So magnitude representation of the binary number system. So in the binary number system, you can feel there are 4 ways to represent the any number system. If you want to represent the any number, there are 4 ways to represent, right? One is called unsigned representation. Second one is called signed representation. Third is called one's complement form. And the second one is called two's complement form. So whenever you want to represent the any numbers, then we can say that into the unsigned form, signed form, one's complement or two's complement, we can write. Any binary representation is there, right? In 101010 form, like, okay. How we can do it? So everyone, suppose plus 5 is there and you want to represent into the unsigned representation, we can write like a 101. This is a plus 5, that's it. Now if you want to write the plus 5 into the signed representation, we have to write the number 101, and into the MSB we have to use 0 if the number is positive and 1 if the number is negative. So actually 3 digit will represent a number. The fourth MSB will represent the whether the number is positive or the negative. So if the 0 is there, it means we can say that that number is nothing, it is just a positive number. For the negative, we have to use the 1 into the MSB. Now in the one's complement form, if you want to represent the plus 5 is represented in the one's complement form similar as the signed representation. So if you want to represent into this is called 0 1 0 1. Okay. If you want to represent the plus 5 into the 2's complement form, then also it's similar like the signed representation. So it's called 0 1 0 1. It means, my dear friend, we can make a very simple statement, and that statement is called, everyone, कि whenever the any number is positive, do not do the complement. If you complement it, that will become the negative number, right? So if any number is positive, then in those particular number, signed representation, one's complement and two's complement, all are basically the same, right? All do not change it, right? The same value you will get. In the similar manner, if I will discuss about how we can write into the minus 5, everyone. Minus 5, negative number we cannot write into the unsigned representation. Unsigned representation is used only for the positive number, right? Now, in the signed representation, if you want to write the minus 5, first you have to write 5. 5 is called 1, 0, 1. And then you have to take MSB, you have to put 1. So it will become 5, and due to this one, it will become minus 5. Okay. If you want to represent the minus 5 into the one's complement form, then first take the plus 5. Take the plus 5. Any number you can write plus. And take the complement. Complement I will discuss in detail later on, right? In the 2 days only, right? But at this particular moment, I am just giving you the brief idea, right? So if take the one's complement of it, how we are going to take the one's complement? So positive number, if you take the one's complement, it will become negative number. If for the negative number, if you take the one's complement, it will become positive number, right? So if you take the positive number and if you take the one's complement, so it will become 1 will become 0. Always complement the value. 1 will become 0, 0 will become 1, 1 will become 0, and this 0 will become 1. So it is called 1 0 1 0. This is a negative 5. Because this is a plus 5, we have taken the one's complement, so it will become minus 5. In the similar manner, if you want to write the minus 5 into the 2's complement form, there is a 2 way. The first one is called, the general method is called, first you have to find the minus 5 into the one's complement form and then add 1 into the LSB. You will get the 2's complement. And there is the one directly the short trick also. take the 2's complement of this number. If you take the any positive number, and if for the any positive number, if you take the 2's complement, then that number will become negative number. So if you take the 2's complement of this particular number, we'll move into this direction. Directly I am giving you the shortcut. So we have to move into this direction and do not change the number till we will receive the 1. So if we move from, it means we are moving from LSB to MSB, right? From LSB towards MSB, and do not change the digit until you will receive the first time 1. So if we'll move it, the first time, coincidentally in the first position LSB we are getting 1. Now every digit you have to interchange, right? So 0 will become 1, this 1 will become 0, this 0 will become 1. So this is called, so we do not change the number till the first time we will receive the 1. After that we are changing it. So this is called minus 5. So if the positive number is there, if you are taking the 2's complement, then it will become minus 5 in 2's complement format. If it is plus 5 and we are taking the 1's complement, then it will become minus 5 in the 1's complement form, right? So one thing you can understand in very simple, if any number is called P, if you will take the complement, whether it is a 1's complement or 2's complement, that number will become minus P. So negative sign will be there, right? Okay, everyone. Now, but we cannot expect the question from here, right? Like this. Suppose one question I am giving you, one more question I am giving you, and then some very, very important conclusion we are going to make, right? In this particular question, right? First, if the plus 13 is there, can you write in the unsigned, signed 1's complement, 2's complement? In the similar way, if I am asking about the minus 13, you have to write into the unsigned, signed 1's complement, 2's complement. Can you write it, everyone? So if plus 13 is there, how we are going to write into the unsigned? 8, 4, 1. So 8 plus 4 plus 1. So this is called plus 13. Now if you want to write plus 13 to the signed representation, first you have to write the 13. And now into the MSB we have to add 0. Now this is 13, due to this 0, this is a plus 13. Now for the 1's complement, if you write the plus 13, it's the similar like the 1's complement. If you want to write plus 13 to the 2's complement, again the similarly like signed representation. So everyone try to understand. If they will ask about 0, 1, 1, 0, 1, and if they ask the question ki it is written in the 1's complement form, either into the 2's complement form, what should it already written in the 1's complement form? What should be the decimal equivalent of it? So for the finding the decimal equivalent, first you have to focus on the MSB. MSB is 0, do not change. Directly we can say that 8 plus 4 plus 1. So 13, we can say that it is a plus 13. So if the MSB is 0, do not change. If that number is written in the 1's complement. So there are two type of question we can expect. One type of question, they will ask the number. And then they will ask what should be, if this number is written in the 1's complement or in the 2's complement form, what should be the decimal equivalent of those particular number? That is the meaning of this. Second type of question we can expect, 0, 1, 1, 0, 1 is there, and they will ask, find the 1's complement of this. Whenever they are asking any number are basically given and they are asking, write the 1's complement. It means this is working as an operator only. So we have to change the digit. Alright. Do not care about whether in the MSB the 0 is there or LSB the 0 is there. Because they are asking the question, you have to convert into the complement form. So you have to work as an operator. Right. And the second part is called, if they ask the question, ki number is written in the 1's complement, what should be the equivalent decimal? Then you have to focus on the MSB. Whether the MSB is 0 or 1. If MSB is 0, number is positive, do not change anything. Directly you can convert it into the decimal, right? Okay. Even if the question is given 0, 1, 1, 0, 1 is given into the 2's complement format. It written in the 2's complement. What should be the equivalent decimal? Again, you have to focus on the MSB. MSB is 0, do not change it. Directly we can comment, okay, this is even in it is written the 2's complement, it's a positive number. So directly we can make a statement, it is a plus 13. Hope you guys understood. Now everyone try to understand. The second part of this in very simple manner, we can say that. Suppose, if I'm asking what should be the minus 13 into the into the unsigned representation, no, we cannot write. Because unsigned representation is used only for the positive number. We cannot write into the negative number. So unsigned representation we cannot write. Now, minus 13 if you want to write into the signed representation, how we are going to do it, everyone? So minus 13 if you want to write the signed representation, first write plus 13 13 only. This is 13. And in the MSB, we have to add 1. Due to this one, we can say that this is a negative. Right? Okay. Okay. Now, if they are asking about to write the minus 13, how we'll get the negative number? If write the positive number and then take the complement. If any number is p, if you take the complement, it will become minus p. So number is positive, if you take the complement, it will become minus negative number. So now minus 13, if you want to write into the ones complement form, first you have to write plus 5. Plus 5 is written like the sign representation 0, 1, 1, 0, 1. And now take the ones complement of it. So how we are going to take the ones complement of it? Convert the 0 or replace the 0 with the 1 and 1 with the 0. What should be the actual method? I will discuss just after the 10 minutes, right? But at this particular moment, we can say that we can convert this 1 as a 0, this 0 as a 1, this 1 as a 0, this 1 as a 0, this 0 as a 1. This is minus 13 into ones complement form. Now, if the question they talk about, write the minus 13 to the 2's complement format. So first, you have to write the plus 13 to the 2's complement. This is plus 13. Now take the 2's complement. Directly we can take the 2's complement. You can apply the shortcut. How? We have to move into this direction from LSB towards MSB. And do not change the digit until you will receive the first time 1. So we are moving it. The first time in the first position we are getting 1. Now we have to complement all values. So 0 will become 1. This 1 will become 0. This 1 will become 0. And this 0 will become 1. So this is 1, 0, 0, 1, 1. This is called nothing, it is just a minus 13. Now we can expect the question, everyone try to understand. We can expect the question like, they will give you 0, 1, 1, 0, 1 and one question they will ask about 1, 0, 0, 1, 0 suppose. And they are asking, this number is written in the ones complement format. This number is written in the ones complement format. What should be the equivalent decimal? The first question they can ask, what should be the equivalent decimal of this number? So if number is written in the ones complement and you have to find out what should be the equivalent decimal, then you have to focus on the MSB. If we'll focus on the MSB, MSB is 0. So if the MSB is 0, we can make a statement it is a positive number. And directly if the number is positive, do not change it, 8 plus 4 plus 1. So this is called plus 13. Now in the question they have given, okay, this number is already written in the ones complement. You have to convert into the equivalent decimal. We have to focus on the MSB. MSB is 1 means definitely this is a negative number. Definitely this is a negative number. So if number is negative, now you have to, if number is negative, so how we are getting the negative number? By making the complement of the positive number only. So first anyhow you have to take the complement of it. So actually you have to find out those positive number. So if number is 1, MSB is 1, we are complementing it. 1, 0, 1. It's a 1 complement, that's why we are taking the ones complement. So it will become plus 13. Oh, it's a plus 13. So we have complemented. If it is a P, so it will become minus P. Only the sign changed is there. So this is a 13. So definitely it will be a minus 13. So the conversion minus 13. Whatever the P is there, minus sign is there. So this is called 13. So it will become minus 13, right? Or we can say that if it is P, so this will become minus P. This will take the complement. Anyhow, in those numbers, only the one sign is there. So we can say that this is a 13. So this will become minus 13. Understood everyone? Write down yes or no. Everyone write down yes or no. Now, let me give you the one question and then one by one we are going to understood the approach, right? Suppose if I am asking the one question like 0, 1, 1, 1, 0, 1 is there or 0 is there. Same question 0, 1, 1, 1, 0, 1, 0. 0, 1, 1, 1, 0, 1, 0. If all these numbers are written in, this number is written in signed form, this number is written in ones complement form, this number is written in two's complement form, and what should be the equivalent decimal? Can you find it? Can you find the equivalent decimal of this particular number? So if this is number given and you have to find out into the equivalent decimal, again you have to first focus on the MSB. MSB is 0, so number is positive. So this is a number 1, 2, 4, 8, 16, 32. So 32 plus 16 or 32 plus 8, so 40, 40 plus 16, 56, 56 plus 2, so 58. So directly we can say that this number is called plus 58. Right. Sir, can you solve more? Ricky, definitely I'm just going to solve it. Don't worry. If this number is 0, if I will ask what should be the decimal equivalent of it? Again, if number is written in the ones complement, MSB 0, definitely it's a positive number. Positive number, do not change it. Directly we can say that this is also plus 58. MSB is 0 and written in 2's complement. This is also the same, plus 58. Do not change. But in the similar question, if I will ask everyone, if these three numbers, right, the same number are there, this is written in the signed form, this is written in the ones complement, written in 2's complement, what should be the equivalent decimal? Nishu. Now, if you want to solve it, how we are going to do, everyone? So first you have to focus on the MSB first, right? MSB is 1. So definitely we can say that this is a negative number. Negative number into the signed form. So number is only this. So 1, 2, 4, 8, 16, 32. 32, 16, 8, 4, 2, 1. So we can say that this is called 20. So 32 plus 20, 52 plus 2, so 56 I think. So this number is called minus 56. 20, 32 plus 20, 52 plus 50. Oh, no. 20, 52 I think. 52 minus 52. 20 52 54 actually. क्या लिख रहा हूँ मैं? This is minus 54, right? Okay. Now, if now the question is given, if this number is written in ones complement, what should be the equivalent decimal? So if number is written in the ones complement, you have to find out in the equivalent decimal. First, you have to focus on the 1, MSB. MSB is 1, so definitely this number is negative. So MSB is 1, so definitely we can say that this number is negative. Now, if this number is negative, so we have to find out the equivalent decimal of this particular number. How we can say that? So first, if number is negative, so definitely any positive number is there, and we can take the, we have already taken the complement of it. Then only this number will become negative. How we will get the negative number? By taking the complement of the positive number, right? So इसका complement लेके बिल्कुल सही. So इसका we have to take the ones complement of this. So it will become, because this number is negative. So positive का ones complement, so it will become 1 0 0 1 0 0 1 0. If you take the, now you can observe, if it is a positive number, we know that this is a positive number. If we have taken the ones complement of it, so this number will become. So whatever this number, if you use this negative sign, that is this, right? So this is a 1, 2, 4, 8, 16, 32, 64. 64 plus 8. So that it will become 72. 72 plus 1. So 73. If this number, if they will ask, we can say that plus 73. So this number, if they are talking about, minus 73 is the answer. Minus 73 is the answer. Everyone understood? In the similar manner, if they will ask about okay, find the 2's complement of this number, how we are going to do? First, you have to focus on the MSB. Now the MSB is 1. It means this number is negative number. We can say that MSB is 1. So this is a negative number. Now it is written the 2's complement. So we have to deal with the 2's complement only. So we have to take the 2's complement of this number. If we'll take the 2's complement of this number, it will become 0. Now what? Because do not change until you will receive the first time 1. So we are moving from LSB to MSB. Do not change until you will receive the first time one. So 0 and 1. Now we have to change the value. So 1 will become 0, 0 will become 1, 1 will become 0, 1 will become 0, 0 will become 1, 1 will become 0. Now you can observe this is called 1, 2, 4, 8, 16, 32, 64. So 64 plus 8 plus 2, so it will become 74. This is actually plus 74. So if you have taken the 2's complement, this value you will get. So it is a plus 74. So definitely this is a minus 74 is the answer of this question. Hope you guys understood how we are going to do it. If you have understood this point, let me give you the few questions also, right? The number given below written in 1's complement, all these numbers are basically given in the 1's complement. You have to convert into the equivalent decimal, everyone. So I have given that 8 question, you have to convert into the equivalent decimal, right? And in the similar question, the same question, if written in the 2's complement, then also you can write the equivalent decimal. So 16 question I am giving you. The one if this is written in the 1's complement form, what should be the equivalent decimal? If it is written in the 2's complement form, what should be the equivalent decimal? So everyone just do it. Everyone. Just solve this question. Everyone. So if you'll observe the first one, everyone, this is 0. So if number is written in the 1's complement and MSB is 0, so directly we can convert it. So it's called 1, 2, 4, 8, 16, 32 and 64. So 64 plus 32, 64 plus 32, अरे यार एक तो नंबर बहुत पास में लिख दिया मैंने, 1, 2, 4, 8, 16 हटा देता हूँ, 32 and 64. So this is called 40. So 104 plus 4, 108. So this is called plus 108. Yes, correct. This is called plus 108, right? Do not change. Directly we can write. This is a plus 108. Right? Okay. This is a binary representation only, right? Okay. Now, for this one, if you want to write 1, 1, same question is given. MSB 0. Again, this is the same plus 108. If MSB is 0 and even though number is written in the 1's complement, directly you can convert it. Multiple times 0 is there given, but number is same, so we can say that plus 108. Suppose if this question, if you want to write MSB is 0, but pattern changed, we have to find out. So 1, 2, 4, 8, 16, 32, 64. 64 plus 16. 80, 80 plus 6, 86. So it will become plus 86. Due to this, right? Even though number is written in the 1's complement, the conversion directly we can say that. 1, 2, 4, 8, 16, 32, 64. 64 plus 16. 80. 80 plus 2 and 4, 86. Yes, correct, 86. Now, oh, this number is 1 in the MSB. So definitely, if this number is written in the 1's complement, MSB is 1, definitely we can say that this is a negative number. So negative number is there. So we have to complement the value. 1's complement is there. So take the 1's complement. 1, 0, 1, 0, 1, 0, 0. 1, 2, 4, 8, 16. 16 plus 8, 24 plus 1, 25. So this is called minus 25. 1, 0, 1, 0, 1, 0. 1, 2, 4, 8, 16. 16 plus 8, 24 plus 1, 25. Yes, minus 25. Understood everyone? Write down yes or no. This one also we can say that in the similar pattern we are getting minus 25. Right. This is minus also minus 25. If the number is 21 is given. हाँ हमने गलत लिख दिया क्या? All are given 25. 1, 0, 1, 0, 1, 0, 0. 1, 2, 4, 8, 16. So, 21. Yes, correct. 21 is there, not 25. This is a minus 21. Yes, absolutely correct. Minus 21 is there. Correct. So, this is a minus 21. So, we can make a statement also up to this portion. Even though if you will extend this one n times, does not affect the number. Yes, Nishu. So, we can make a statement whenever any number are basically written in the ones complement form, then whatever their MSB, if the MSB we can extend, it does not make any difference. If MSB is 0, if we'll extend the 0, does not make any difference into the number. Look at the example number 1, 2, 3. Right? If any number is in the ones complement and if number is negative, means in the MSB we are getting 1. So, if we'll extend that one, it does not make any difference. Minus 21, it is also minus 21. If this one, if you'll observe, this is called plus 0. This one, okay, complement we have to take 0, 0, 0, 0. So, this is 0, so this is minus 0. This is also the major drawback of the ones complement. There are two different ways. They are basically taking the positive 0 and negative 0. They are basically representing to some different manner. 0 is a 0. So, 0 we are representing into some different manner. There are two representation of the 0. It is a negative, you can say that it is drawback of the ones complement. And to remove this drawback, we are using the 2's complement, right? Because 0 is 0 only, right? So, we can say that everyone. So, we have discussed whenever any numbers are written in the ones complement, then extension of the MSB does not affect the number. That's the first point you can understand. Second point, there are plus 0 and minus 0 are written in different way in the ones complement. And it is a major drawback of the ones complement. And to remove it, we are using the 2's complement format. So, suppose the same question is given in the 2's complement format. What should be the equivalent decimal? Everyone. If this number is written in the 2's complement format, what should be the equivalent decimal? Everyone. So, if the number is written in the 2's complement, you have to find out the equivalent decimal. First, you have to focus on the 0. 0 is there, directly do not change. So, the same number is there, 108. 108. For the positive number, it's the same, 108. Now, look at here. Okay. Okay, now. If this number, if you'll observe, okay, sir, MSB is 1, so definitely it's a negative number. So, if it's a negative number, we have to take the complement of it. So, we will take the complement. So, we will take the complement, 2's complement of it. So, move into this direction. Do not change until you will receive the first time one. So, we are changing it 0, 1. Now, after that we can change 1, 0, 1, 0. 1, 2, 4, 8, 16. 16 plus 8, 20. It is called 26. नहीं यार, कुछ तो गलत कर रहा हूँ क्या? 21. 1, 2, 4, 8, 16. So 16 plus 4. So it is 22. So this will become minus 22 actually. So this will become minus 22. It is a plus 22. So definitely if we take the 2's complement, it will become the same number. So it will become minus 22. Here also the similar way. It is also minus 22. This is also the MSB M1. So take the similar manner you will get. So this is also the MSB extension concept is applicable in this in the 2's complement format also. Now you can feel this is our MSB. So this is called 0. Now you can feel, oh, MSB is 1. So definitely it's a negative number. So take the 2's complement. It will be moving 1. Now 0, 0, 0. So it is a plus 1. So this will become minus 1. So this one we can say that. Now how many of you understood this point? Yes, sir. If 1's complement, 2's complement are basically given, whether it is a positive number, negative number, we are able to solve the question. Everyone. Write down yes or no. If you have understood this point, everyone try to understand. So what actually I have given the question, if we'll take the P and if we'll take the 1's complement, whatever the value, you have to use the negative sign, right? So it will become minus P in one's complement, in one's complement. As your operator, if you use whatever the number is there, if you take the complement, negative sign you can use. If p is there, so we can say that this is a minus p. If you take the 2's complement, then it will become minus p in 2's complement format. In 2's complement format. Slider कहाँ गया? So it is called in 2's complement format, right? Okay, now let me discuss about the unsigned representation. Already we know that unsigned representation is used only for the positive. So you can unsigned representation, or we can make a one statement used only for the negative positive number. Used only for the positive number. हेमंत बिल्कुल भाई, अगर आप महा रिवीजन भी अगर कर लोगे तो मैं गारंटी देता हूं सिक्वेंशियल सर्किट में पूरे नंबर ले आओगे आप, कोई दिक्कत नहीं, राइट? ओके, नाउ so unsigned representation used only for the positive number. So if this is, you can say that if this number is, suppose 4 bit are basically given, so from 4 times 0 to 4 times 1 we can write, right? Okay, and their decimal conversion will be, this is plus 0, this is 1 2 3, like this only, this is plus 8 plus 9, because directly it will represent a number, right? So for the 4 bit, if I will discuss, then the representation will be a total decimal number we can use from 0 to 15. So for the 4 bit 0 to 15, 3 bit 0 to 7, right? So 5 bit 0 to 31, 6 bit 0 to 63. So we can say that, my dear friend, n bit is there, so 0 to 2 raised to power n, 2 raised to power n minus 1. So n bit range is called 0 plus 0 to 2 raised to power n minus 1. That's what the basically range of the unsigned representation. Now in the similar manner, if I will discuss about the signed representation, everyone, if I will discuss about the signed representation, so signed representation of n bit, can anybody give an answer? In signed bit, suppose 4 bit are basically there, 4 times 0 to 4 times 1 we are writing, and I'm asking what should be the decimal equivalent of it. So we can observe, okay, MSB is 0, because the digit magnitude will be represented by this digit only. The MSB will represent whether that number is positive or negative. If MSB is 0, the number is positive. If MSB is 1, the number is negative, my dear friend. So we can say that, everyone try to understand in this particular question, we can say that. So it is 0 plus, 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 plus. This is 0, 1, 2, 3, 4, 5, 6, 7. So plus 0 to plus 7 we can write. Okay. And now if you want to represent into the decimal, everyone, if signed is there, now if you will focus on the 1, so this is a negative number, we can say that, and this will represent the number. So minus 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So we can write from minus 0 to minus 7. So in the decimal representation, if you want to discuss for the 4 bit, minus 7 to plus 7, it means minus 2 raised to power 4 minus 1. That will become 2 raised to power 3. So it will become 7. Minus 1 we have to do. 2 plus 2 raised to power 4 minus 1 minus 1. So in the 4 bit we can write like this. So for the n bit we can write like minus 2 raised to power n minus 1 to 2 raised to power n minus 1 minus 1. This is called 4th bit 7. This is called 7. So minus 7 to plus 7. Plus minus, if the 5 bit is there, minus 15 to plus 15, like that you have to understand, right? Okay. So range is very important, you can expect, right? Okay. Now in the ones complement, if I will discuss, everyone, if in the ones complement it is given and we are converting to the decimal equivalent. It is in the ones complement given. Already we have solved the lots of question. We know that if MSB is 0 in this side, directly we can see that this is a positive number. If MSB is 1, so it is a negative number. So if it is a negative number, we can take the complement 1, 1, 1, 0. This is a plus 7, so this will represent minus 7. Like that you have to solve. So this is also from minus 7 to plus 7 we can use. So range is in the ones complement also. The range will be the similar like the signed representation range. From minus 2 raised to power n minus 1, minus 1 to 2 raised to power n minus 1, minus 1. That's what we can say that for the ones complement format also the range is same. Now in the twos complement format, if you want to write, look at here. In the twos complement format, if you want to write, if the number is suppose 4-bit we are talking about, right? So from 4 times 0 to 4 times 7 we can write, right? So if the MSB is 0, definitely we can say that this is a positive number, so here do not change. But here we can say that, okay, this is a 1, so definitely it's a negative number. Now we have to take the twos complement of it. So if you take the twos complement, do not change until you will receive the 1. So last time we are getting at the MSB, we are getting 1. So this is a plus 8, so we can say that this is a minus 8. In the similar manner, everyone. Suppose this one is written the twos complement. We have to convert it to equivalent decimal. So MSB is 1, so definitely it's a negative number. Move into this direction. Do not change until you will receive the first time 1. So here we are getting 1. Now change the value 1 and 0. So it is a plus 6, so definitely it's a minus 6. In the similar manner you can write. So now you can feel the range is in the negative side, one more value is there. That is from minus 8 to plus 7 in the decimal we can write. So in the negative side, whatever this minus 1 value is greater. So you can remove this minus 1 only, right? So we have removed this minus 1. So minus 2 raised to power n minus 1 is there. In the positive up to 7 is there. So that's why the minus sign we have to write here. Understood everyone? Write down yes or no. Everyone please respond. Up to this portion everything is cleared. Okay. And one word is very important. The one value is greater than the twos complement. Okay, yes. Now one thing more you can understand what we have learned. In the unsigned representation 2 raised to power, this 1 we have to remove. 2 raised to power n minus 1. In signed form and 1's complement with the form same value you will get, and 2's complement this is, right? Okay. So this is the range you can understand, right? You can write it. For the unsigned form, for the signed form, for the 1's complement and for the 2's complement form. One thing more you can understand here, guys. Whenever any arithmetic and arithmetic operation is going to happen, and if range will come out of the defined range, then overflow will occur. So if the range are basically coming out of the defined range, then the overflow will occur. So we can say that if any number is coming after the arithmetic, if any number is coming after the arithmetic operations out of the range, out of defined range, then overflow will occur. Overflow having the different approach to find out that overflow. This is the one of the approach, right? Then overflow will occur. This is called overflow, right? Then we can say that the overflow is going to be occurred. Now let me discuss the few questions of the overflow also, but before going to that, let me take the one question. Let me give you the one question, everyone. Just give me the answer of this question. If P is given, Q is given, R is given, if P, Q, R is written in 2's complement representation, then what is the value of P plus Q plus R in decimal, everyone? What is the value of P plus Q plus R in the decimal, everyone? Look at here. If it is written in the 2's, the question is given, all are basically written in the 2's complement format. So first you have to focus on the MSB. MSB is 0. So definitely this is a positive number. Directly we can write positive, and we can say that 1, 2, 4, 8, 8 plus 2. So this is called plus 11. This is written negative, so definitely it's a negative number. So we can complement it 0, 1, and then we have to complement 0, 1, 0. So this is 10. So this is a minus 10 actually. This is a 7. So this is called plus 7. If it is written in the 2's complement format. Now you have to find out P plus Q plus R into the decimal. P plus Q plus R into the decimal. So 11 plus minus 10 plus 7. So 18 minus 10. So this is called 8 into decimal is the answer of this question. 28? 8. Yes. 8 is the answer of this particular question. Alright. Hope you guys understood. Now if you have understood this point, everyone, now let me discuss about the complement system first, and then some arithmetic operations also we are going to discuss. First, if I will discuss about the complement form, everyone try to understand. Generally we are going to deal with the binary number system, right? Decimal number system, hexadecimal number system, octal number system, base 8. Base 8, that is octal number system, right? So generally these 4 number system which we are going to deal very much in the digital electronics or digital logic, right? Okay, now, okay, शिवम वही तो चल रहा है बेटा, नंबर सिस्टम से शुरू हुआ है देखो. Now everyone try to understand, it is a base 2. So everyone, if it is a base 2, we can say that this is a binary number system, this is a base 8, decimal, hexadecimal. So now, if there are two type of, if any number system having the base R, then R is basically split into the two part, two number systems, two complement form is there. One is called R minus 1's complement and the second one is called R's complement. Now we have a two different approach. Directly we can find out the R minus 1's complement, then we can convert into the R's complement also. And one approach is also directly we can find out the R's complement, and from the R's complement we can find out the R minus 1's complement. Both you can do. Only the difference is called, if you have calculated the R minus 1's complement and if you want to go into the R's complement, then add 1. So first find the R minus 1's complement and then add 1, so it will become the R's complement. And if you have calculated the R's complement, then subtract 1 so that you will get the R minus 1's complement. That's the meaning of this. यहीं पे होगा, यहीं पे, right? Okay. So R minus 1's complement, if you discuss, everyone, base 2 is there. So we can say that if base is 2, R is 2, so 2 minus 1, it will become 1's complement and 2's complement. That's why I have discussed earlier also, कि whenever the binary number system is there, only two type of complement we are going to discuss. The one is called 1's complement, second one is called 2's complement. Suppose we are talking about the base 8 number system, that is called octal. So 8 minus 1, in which those number systems, 7's complement, the 8's complements are the number which we are going to do. Suppose the decimal number system is there, that is called base 10. So in the decimal number system, 9's complement and 10's complement, R minus 1. So 10 minus 1, so it will become 9's complement or 10's complement are basically there, right? Now we can say that hexadecimal is there. So we can say that R minus 1, so R is called 10. So 10 minus 1, 15. 15's complement generally used as a F's complement. So we can write F's complement and 16's complement. These two complements we are going to discuss, right? Right, okay. Okay, now, so everyone try to understand. So we can say that base 2, base 8, decimal, hexadecimal, these are the basically the things we can understand. Now everyone try to understand. If you have understood this point, everyone. Right. R's complement, 2's complement, 8's complement, 10's and F's complement. ठीक है. Now one by one we are going to discuss about. First we are discussing how we are going to find out R minus 1's complement, and from the R minus 1's complement how we'll solve or how we'll calculate the R's complement. After the some part 5 or 10 minutes we are going to discuss how directly we'll take the R's complement, and from R's complement how we are going to convert the R minus 1's complement, right? So everyone, first suppose if we are talking about the 1's complement and we are talking about into the binary number system. So in the binary number system, suppose if I am asking the question 10110, and what should be the 1's complement of this? Suppose I am asking 10110, and I am asking find the 1's complement of this. You have to find out the 1's complement of this. So everyone try to understand how we are going to do it. Earlier I have given the idea directly कि convert the 0 into 1 and 1 into 0. That's the meaning of this. But actual approach is, if this is a 1, 2, 3, 4, 5, 5-bit number is there. So in the binary number system, what should be the maximum number we can write from the 5 bits? From 5 bit, the maximum number is called 11111. If you want to represent this number in the 5 bit, we can say that maximum of 2 raised to power 5 minus 1. That's the meaning of this, right? Okay. Subtract this number from here. So if you subtract this number, it will become 1, right? 1 minus 0, so 1, 1 minus 1, 0, 1 minus 1, 0, 1 minus 0, 1, 1 minus 1, 0. So this one, the number you are getting. Now everyone try to understand. So 1's complement, 1's complement of this number is called like this. Now if you want to discuss about in the decimal, it is just a number written. It is not written the 1's complement. This is a decimal. So decimal is called nothing, it is just a 22. If you want to represent 1, 2, 4, 8, 16. What actually I am asking, everyone try to understand. I have asked the one question कि convert 10110 into the 1's complement. That's what the question I have asked. I have never told you that this number is written in the 1's complement. No. I am asking convert into the 1's complement form. So directly the operator, as an operator we are using the 1's complement. So directly 1 will become 0, 0 will become 1. Like this you have to do. So 1's complement of this number is like this, and 1's complement of this number is like this. That's the meaning of this. Now if you'll follow कि what should be the decimal equivalent of this particular number. So decimal equivalent of this number is called 22. Forget about the sign. I am just observing. I am not saying that this number is written in the 1's complement, 2's complement. I am saying any number is there. What should be the decimal equivalent? So this is called 22 and this is called 31. So if this is 31, this is 22. So if you subtract the 22, what should be the value we are getting? 9. So the answer we are getting 9 in the decimal. So you can feel both are basically, this one is basically correlated. So directly you can observe it also कि 2 raised to power r minus r नहीं d. How many digits are there? 2 raised to power d minus 1 minus whatever the number is basically given. You have to subtract it, right, into the number. That number into base r. You have to subtract it. और इसकी जगह मैं 2 की पावर लिख देता हूं, r की पावर लिख देता हूं, r raised to power d minus 1. So this is called nothing, it is just a, right, r's complement, right, r minus 1's complement. This one value, r raised to power d. D means what? How many digit is there? 5 digit. So r raised to power d minus. One thing more you can understand. If you want to subtraction is happened, then both must be into the same base. Must be into the same base. So if it is into the r, we have to find this is also must be into the r base. Then only the subtraction is going to happen. हाँ कर सकते हो, ये तो शॉर्ट ट्रिक है, पर आपको क्वेश्चन किस में पूछा गया निशु, ये इसके ऊपर डिपेंड करता है. आपको क्वेश्चन 1's कॉम्प्लीमेंट में निकालने के लिए बोला गया है कि आपको कोई डेसिमल में निकालने के लिए, या फिर बाइनरी में बोला गया है कि 1's कॉम्प्लीमेंट, इसके ऊपर डिपेंड करता है. लुक एट हियर एवरीवन. Suppose I am giving you the question, what is the 1's complement of this number? So this is as a operator they are talking. Do not focus कि okay MSB में 1 दिया हुआ है, MSB में 0 दिया हो. No. MSB of the 1 and 0 you have to focus whenever you want to convert into the corresponding decimal. If they will ask, okay, this number is written in 1's complement, what should be the decimal equivalent? Then only you have to focus on the MSB, whether MSB is 0 or 1. At this particular moment, they are basically considering like you have to direct conversion of the 1's complement they are talking. So you can do it like 1, 0, 1, 1, 0, 1 is there. So what should be the maximum? How many digits? 1, 2, 3, 4, 5, 6. 6 is there. So we can take 1, 2, 3, 4, 5, 6 maximum number. Subtract it. So 0, 1, 0, 0, 1, 0. This is the ones complement of this. Directly we are getting the answer. Into the decimal format if you want to write, everyone. From the other way if you want to solve it, sir, here the base is called 2, R is called 2. Digit is called how many? 1, 2, 3, 4, 5, 6. So digit called 6. So we can say that R is to power D minus 1 minus 1, 0, 1, 1, 0, 1 in base 2. So this one also you have to write into the base 2 actually. This one also you have to convert into the base 2, and then it, because the subtraction is happened into the same base is going to happen, right? If both the number system numbers are basically in the same base, then only we can do the complement, right? Subtraction or addition, isn't it, everyone? Okay. Now if you have understood this point, let's move into the next, right? Okay. Now how we are going to find out the 2's complement of this? Yes, correct, Nishu. Now how we are going to find out the 2's complement of this? So 2's complement, if you want to find out, means we are talking about the R's complement from the R minus 1's complement. So we have to take the 1's complement, then add 1 into the LSB. Suppose we are taking 1, 0, 1, 1, 0, 1. What is the 2's complement of this number? So we can say that if you want to find out the 2's complement, first we have to take the 1's complement. 1, 2, 3, 4, 5, 6. 1, 0, 1, 1. बहुत ही easy topic है, जबरदस्ती मैं इसको और explain करने के लिए थोड़ा detail में चला गया. Otherwise it's very easy topic, not that much of detail, right? 1 minus 1, 0. 1, 0, 0, 1, 0. This is a 1's complement of this. Now if you want to find out the 2's complement, take 1. So it will become 1, 1, 0, 0, 1, 0. This is like this. Very simple. So this is a 2's complement. So this is a 2's complement of it, right? Hope you guys understood. Now if you have understood how we are going to do it, what should be the meaning of this 2's complement, right, everyone? Now suppose in the base 10 number system is there. Just give me 1 minute, guys. Just give me 1 minute and find the 9's complement of this, right? Now everyone try to understand. Now if you want to take the 9's complement of it, take the 9, 9, 9, subtract, because in the decimal the maximum digit is called like this, 2, 3, 9, and convert it. So it will become nothing, it is just a 9, 9. So 0, 7 and 2. This is the answer. 9's complement of this. 10's complement if they are talking about, then answer will become 2, 7, 1 in the 10's complement. One thing more direct shortcut you can also, base is called 10, so 10 raised to power digit called 3 minus 1 minus 739 into base 10. So it must be base 10. So it will become 999 minus 731. So answer is called 270. From here also you are getting the same, right? So here also you are getting in the same manner. Now if you have understood, next, suppose 6, 2, 3, 7, 9's complement, very easily you are able to do it. So I am not solving it, right? So 10's complement, 9's complement plus 1. So R minus 1's complement, if you know, if you'll add 1 into the LSB, it will become R's complement. So we already know that. Now in the octal, if you want to discuss, the R minus 1's complement is called 7. So if I will discuss about what is the 7's complement of the number given 7254 base 8. So 7254 base 8 is there. So in the octal number system, what should be the maximum number of 1, 2, 3, 4 number digit is there? 7, 7, 7, 7. So we have to subtract this 7254 from this. If you want to find out the 7's complement, so it will become 3, 2, 5, 0. This is into the base 8 is the answer. 7's complement. So it's not that much of difficult question you can expect. It's very easy question, right? Okay. Now, directly if you want to find out the R's complement of digit n. So if I'm talking about R's complement of the n, only -1 we are subtracting, forget about this. R raised to power D minus n you have to do. And most important thing is, if you want to find out in the base R, the both must be into the base R. That's the most important thing. Alright. Suppose if I'm asking the question 731 in the base 10, what is the tens complement of this? So you have to understand 739 tens complement. So what should be the R is called 10. What should be the D? How many digits are basically there? So 1, 2, 3, 3 minus. What should be the, you can say that the number is there, already direct number is given into the decimal, 731, 739. And this is also into the 10, we can say that. So it will become 1000 minus 739. Now everyone try to understand how we are going to do the subtraction 1000 739. Subtraction if you'll do, everyone try to understand. Now अब मुझे subtraction भी सिखाना पड़ेगा, ध्यान से समझिएगा. Because this subtraction is applicable into the everywhere. Some of the people can think, okay, base is changed, the subtraction rule is going to be changed. No, all are basically the same. So how subtraction is happening? 0 minus 9, it's not going to happen. So here the 1 minus is subtracted and it will plus 10 is going to happen. Because we are dealing with the base 10. So plus 10 is there. If we are dealing with the base 10, 2, so plus 2 is there. If we are dealing with the base 3, so plus 3 is there, right? So this is called 10, 10 minus 1, so it will become 9. 9 minus, so first 10 minus, so it will become 1. Now minus 1 is there. So minus 1, we cannot subtract the 3. So we can take this from here. So it will become plus 10. So plus 10 minus 1, so it will become 9. 9 minus 3, so we are getting 6. And here minus 1. Now from minus 1, 7 we cannot subtract. So we can take 1. So it will become 10. So this will become nothing. It is 10 minus 1, 9. 9 minus 7. So it will become 260. So answer is called 261. So 261. It's a very simple. Now suppose if I'm asking the one question, A, B, 2 base 16, find the 16th complement of it. So 16 complement if you want to discuss, so we can say that everyone, A, B, 2 base 16th complement. So base is called what? Base is called what? 16. So we can say that base is called 16. How many digit is there? 1, 2, 3. So 16 raised to power 3 minus that number, right, into A, B, 2, this is 16. Whenever you write 16 raised to power 3, this is into the decimal, we can say that. 16 raised to power 3 if you will convert into the decimal. But we have to write into the 16. So 16 raised to power 3 means 1 and 3 times 0. If you will write into the 16. So always sometime the people may think, no, it's not FFF. FFF if you will subtract, it will become F's complement, F minus 1's complement. So it will become, you are talking about the 15th F's complement you are talking about, Nishu. I am talking about the 16th complement. Otherwise, if you do like this approach, you have to, whatever the answer you are getting, you have to add 1 into the LSB to get the 16th complement. Okay. So if you do it, how the subtraction is going to be happened, everyone try to understand. 1, 0, 0, 0, 3 times. Always try to understand whenever R raised to power D is there, then in the same base if you want to write, it will become 1 and that times 0. So the similar answer you will get, right, in the 16. Now A, B and 2 we have to subtract. We are dealing with the 16. So how we are going to do it, everyone? So from 0 it's not going to be subtract. So we are taking. So it's a plus 16. We are doing it. So 16 minus 2, so it will become 14. Now, and minus 1. Minus 1 from B is not going to be subtracted, so we are taking this. It will become 16. 16 minus 1, so it will become 15. A means 10, B means 11. 15 minus 11. So 15 minus 11, so you will get 4. So this is a 4 minus 1 now. So this is a 16. 16 minus 1, 5. So this is going to be 5. So D means what? E. So answer is called nothing. It is just answer is called 5, 4E in base 16 is the answer of this. Understood everyone? Write down yes or no. And this is what? This is a 16 complement. And yes, absolutely correct. If you want to discuss about the 15th complement, it's 54D. Everyone write down yes or no. Understood this point? कितने लोग देख रहे हैं भाई? Okay. If you have solved this question, let me give you the one more question, everyone. Find the fourth complement of this. Base 4 is there and base 4 is there. So it will become R's complement actually. So if you want to do it, 1, 2, 3, 4, 5. So we can say that 1 times 40, 1, 2, 3, 4, 5, 50 minus 3, 2, 1, 0, 2. Now it will in the base 4 and this is going to be in the base 4. Directly we can do it. 1 time 40 into the... Now the subtraction is happened like 1, 0, 0, 0, 0. 3, 2, 1, 0. 1, 2, 3, 4, 5, 5 0 होना चाहिए. 4 0 लगा दिया मैंने. Sorry. One, 2, 3, 4, 5 0. 3, 2, 1, 0, 2. Now how subtraction is happening? Look at here. 0 में से 2 नहीं होगा. So this is a base 4 we are dealing with. Those 4 we can say that. So 4. So it will become 4 minus 2. So it will become 2. Now again we can take the 4. 4 minus 3. 3 minus 0. So it will become 3. Now it will become minus 1. So it's not going to be happen. So 4 minus 1. So it will become 3. 3 minus 1. So it will become 2. Now you can take 4. 4 minus 1, 3. 3 minus 2, so 1. 3 minus 3, so 0. This is the answer. We can say, everyone try to understand. Actually, the approach is called 4 raised to power 5. Right? 4 raised to power 5 into the base 4 we have to write minus 32102 base 4. So this one 4 is to 5 is into the decimal. If you want to write into the base 4, then it means 1 and 4 times 0. 5 times 0 is there. The meaning of this one into the base, so 1 and 5 times 0 is there. Hope you guys understood, right? Can anybody give an answer of this question? Everyone just give me the answer of this question. Everyone. The solution of the quadratic equation x square minus 11x plus 22 equal to 0. Right. X square minus 11x plus 22 equal to 0 are x equal to 3 and x equal to 6. So everyone try to understand how we are going to do it. There is a several way, right, to solve this question. Alpha by beta 22 is given, alpha into beta 11 is given. We have to convert into the base 10. So this is all right. Correct. So you can solve it. This is the question given. But from this, if you want to find out, this is called x minus 3 or x minus 6 in the decimal if you want to write. Zero. Now the question arises, if both are basically same, then the base must be the same. But here the 11 is there. So this one having the some different base. And this is into the decimal we are talking about. So we can convert it 11 into base b into 9 into the base 10. So b plus 1, if you will convert into the decimal, this one. So it is called 9. So b equal to 8. This is the answer you will get. Very simple. You can use this approach also. By 18 also you can do 22 base of b equal to 18. From here also we can say that. So 2b plus 2 equal to 18. So b equal to nothing, it is just a 8 only. From here also you are getting the same answer. right? Okay. Now can anybody give an answer? If r's complement of n digit decimal number n in the base r is defined for all values of n except n equal to 0, okay. If given number is 1, 4, 3 in base 5, what is the 5's complement of x? 5's complement of they're talking about, right? So 5 complement of this 5, if you want to talk about, it means we know that 1 times 1, 3 times 0 minus 1, 4, 3 in base 5. This one you have to do. That's the meaning of this. This is called 5 complement of this number, 1, 4, 3 base 5. So if you want to do it, 1, 0, 0, 0, 3 digit is there. 1, 4, 3 if you want to subtract. So this is a base 5, so plus 5 is there. 5 minus those, so 2, minus 1 is there. Again you have to take plus 5. So 5 minus 1, 4, 4 minus 0. Again you have to take the plus 5 and minus 4 minus 1, so it will become 3. 302 is the answer of this question. They are talking about the r's complement of number digit, of 5's complement of 1, 4, 3 base 5. It's very simple. It's not that much of difficult question, right? Now you can solve this question. Lots of question I'm giving you as a homework also for this, right? I will upload this sheet into the Get Set Go, right? So in the Google you can search Get Set Go, and I will share into my Telegram channel also. CJ Sir Gate, right? There I will share this PDF also, right? Okay. Lots of questions are basically there. You can solve it. It's very simple. Okay. Okay, one thing more you can understand, everyone. Whenever we are discussing about the arithmetic operation, then generally we are discussing, sir, conversion बता दीजिए, कौन सा conversion? कौन सा conversion बताना एक बार बताओ, वो conversion बता दूंगा मैं, कोई दिक्कत नहीं. किस टाइप के conversion की बात कर रहे हो एक बार थोड़ा सा बताओ. ओके. अर्थमेटिक ऑपरेशन की बात करूं तो एक तीसरा आपके पास एक और है, दैट इज कॉल्ड साइंड addition or subtraction if the number system is binary, right? If the binary number system is there, then there are the three type of arithmetic operations are basically there. 1's complement, 2's complement, and signed addition or subtraction is going to be happen. First, let me discuss about the 1's complement format. Then suppose A and B, right? The first A is also in the 1's complement, B is also in the 1's complement, and if you'll do this addition, suppose A plus B, then directly in the 1A we have to write in the 1's complement, B you have to write in the 1's complement, A, B you will take. Then this result is also in the 1's complement you will get. Now the number is positive. Now the number is positive or negative, it will depends upon the whether the number are basically the 1's complement. So number is positive and negative, it will depends upon the value of A and B actually. Different next topic, sir, different number system convert. Already that Nishu you have joined late. I have already discussed about how the 1x base is converted into the base y. The conversion पहले ही बता चुका हूँ. Okay. Now everyone try to understand. If A plus B, if you'll do, if A is positive, B is positive, then definitely we will get the result. Result you will get into the positive only, right? Okay. If A negative, B negative, result will get the negative only. right? A positive, B negative. Here we can say that if A is greater than B, the result you will get into the positive form. If A is less than B, result you will get into the negative form. Now everyone try to understand. If we are doing, right, now if we'll perform the operation, and in this particular operation, if A having the 4-bit, B having the 4-bit, and result, suppose whatever we are getting, that required the more bits to represent it, then we can say that the overflow will occur. How we can say that? Suppose two positive number we are adding, and result you can observe that will come into the negative, right? So definitely we can say that the overflow is going to be occur, right? If two negative numbers are basically added and result you are getting which is greater than that number, या फिर the sign bit is positive, then we can say that overflow is occur, right? So if unusual things you can observe into the operations, so definitely the overflow is going to occur, right? Okay. Now everyone try to understand how. एक example से समझते हैं. A is also in the ones complement, B is also in the ones complement, and we are doing the operation of it. So by the we know that all this A and B all are basically happen into the ones complement is there, and A plus B if you do, then my dear friend we can say that this is a number. Directly we can also write 0 1 0 1 1 0 0 1 1 0 1 0. If you'll add it, it will become 0 0 0 0 0 and 1. Now you can observe this is positive, but here the observation you can feel it is a negative number if it is written in the ones complement. So definitely we can say that overflow is going to occur in this particular case. By the observation we can also say that 1 2 3 4 5 6, this is the 6th number are basically there. So by the 6th number, what should be the range in the ones complement format? Ones complement format, the range 2 raised to power 6 minus 1 2 plus 2 raised to power 6 minus 1. So we can say that plus 31 to minus 31 we can write. The maximum number should be like this. Here if you'll observe, this is called 1 2 4 8 16. 16 plus 4. 16 plus 4, that is called 20. 20 plus 2, so it will become plus 22. If it will become 16 plus 8, 24 plus 2, it will become plus 26. So if we'll add, it will become 46. So you can feel in the 6th digit we cannot write the 46. So we cannot write the 46 into the 6th digit, right? Are you getting my point, everyone? So if we are not getting, so definitely we can, because the 31 to minus 31 will get. And that's why we can say that this is the overflow condition occur. That's why we can say that the overflow condition is going to be occurred in this particular case. By the observation you can feel this is 0. Okay. Because this is a positive result, it's ones complement, and this is a 1, so definitely we can say that it is a negative number, right? Okay. Oh, sorry, 48, not 46, 48. 48 is there, right? Okay. Now, 1 2 4 8 16 and 32. Now if you'll, even though if you'll observe it, okay, now so overflow condition. So hope you guys understood what should be the meaning of overflow. If the range will come from 48 to this, then only we can say that the overflow is not going to occur, right? Okay. Now we can, how we are going to avoid the overflow? Can anybody give me an answer? How we can avoid the overflow? To extend the bit. If you'll extend the bit, the overflow is removed, right? नहीं, यहाँ से भी यार एक आई थिंक मैम ने कुछ गलती करी है. जस्ट गिव मी 1 मिनट. 0 0 0 1 1 का 0 एक गया 1 1 1 का 0 एक गया 1 1 1 का 0 एक गया 1 1 1 1 दिस इज अ 1 और एक गया 1 और दिस इज 1. हाँ, दिस इज गोइंग टू बी हैपन, राइट? ओके. नाउ एवरीवन, how we can say that the overflow is going to be occurred? If the number is positive and overflow occur, then sign extension we have to use. So if you use 1 bit as a 0, now it will become like this. So 1 2 4 8 16 32. 32 plus 16. 32 plus 16 is nothing, it is just a what? 32 plus 16, 48. So now you will get the correct answer. So this 0 we have used, we can say that, वही मैंने सोचा कुछ तो यहाँ पे गड़बड़ किया. So we can say that here this is not a, this is the overflow condition. So to avoid the overflow, To avoid the overflow, bit extension required. Bit to avoid the overflow, bit extension is basically required in this particular question, right? So in the MSB you have to add 0 because it is a positive number. So when the both number are same, right, when both number in the same sign, then the one condition, maybe the overflow is going to be occurred. When A and B arithmetic operation on the numbers and result is bigger than the range, then the overflow will occur. And third, to avoid the overflow, the bit extension is basically required. We have to extend the bit, right? Okay, now. So otherwise all these operations we already know that how we are going to do it. Look at here. Addition and subtraction operation, if you observe, everyone try to understand, few points you can understand. A and B, suppose in the 2's complement we are doing it. Same thing is applicable in the 1's complement, right? 1's complement वाला मैंने हटा दिया, but दोनों में difference क्या है वो मैं बता देता हूँ. In the 2's complement format, A and B must be in the 2's complement format. Okay. After the addition subtraction, if the result will comes in the 2's complement, after the addition and subtraction, if you'll observe, if you'll do it, the result always comes into the 2's complement form, right? After the addition and subtraction, if final carry and borrow generated, then the final carry and borrow must be discarded to get the correct result in the 2's complement format. Whereas in the 1's complement format, whenever the carry and the borrow is basically a carry will be generated, that carry will be added to get the correct result. That's the most important thing. So same thing I can write. If I will discuss the same thing into the 1's complement format, 1's complement. 1's complement format, the A and B must be into the 1's complement form. Result will also come into the 1's complement form. And after the addition and subtraction, if final carry and generated, then final carry and must be added. Must be added in the result to get the correct result. So in the 1's complement, whatever the borrow will be or carry will be generated, that carry must be added to get the final result. That's the meaning of this, right? Sir, A minus B, so A and 2. Yes, correct. Whenever, if a subtraction is opened, it means there is the one sign. So if we do the complement, the sign is going to be changed, right? Let me take the one question so that you will understand it. एक question ले लेता हूँ. ऐसे एडिशन सब्ट्रैक्शन का एक क्वेश्चन ले लेता हूँ. Suppose this is the question given, right, everyone? Consider the signed binary numbers. A is 0, 1, 0, 0, 1, 0 is given, right? A is given, B is given. Where the B is the 1's complement and MSB is the signed bit, ठीक है? B is the 1's, where? See the signed. Okay, A is the signed form and B is the 1's complement format. Then value of minus A minus B in the 2's complement format they are talking about, everyone. They are talking about in the 2's complement format. So everyone, just give me the answer of this question. Now, first you have to understand A is given into the signed format. This is given into the signed. B is given into the 1's complement. Answer we required into the 2's complement format. So first, if you do the addition or subtraction in the any of the operation, either directly we can convert into the 2's complement format and then you can do it. Minus A into the 2's complement, minus B into the 2's complement, then only you will get the answer. Alright, okay. Otherwise you can do, there is a multiple approach to solve this question. Method 1, if I will solve, everyone try to understand. If I will solve into the method 1, how we can do it in the method 1? First you have to understand if it is a signed representation. So in the decimal if you will convert, MSB is 0, directly we can say that this is a positive number. So if this is a positive number, So A is in the positive number, it is called, directly we can say that 1, 2, 4, 1, 2, 4, 8, 16, 32, 64. So 64 plus 16. So 60, 70, 80, 80, 80, 86. So A will become nothing, it is just a plus 86. It's very simple. A is called बूथ एल्गोरिथम. मैं हमेशा एक चीज बताता हूं, भाई मेरे लिए 15 मिनट का काम है बूथ एल्गोरिथम करवाना, राइट. इट्स वेरी इजी टू डिस्कस द बूथ एल्गोरिथम, जिस जस्ट ए मल्टीप्लीकेशन एल्गोरिथम ओनली. अप्रोच है एल्गोरिथम मल्टीप्लाई करने का. लास्ट ईयर दे आस्क्ड द क्वेश्चन, just because this is out of syllabus, they have not mentioned it. Earlier it was mentioned into the combinational circuit, but in 2016 they have removed from the circuit, but still they ask the question. So ऐसा नहीं कि हर बार वो चीज पूछ लेगा. मेरे इतनी सारी चीजें हैं जो आने के लिए संभावना है, जिसके लिए मैं शॉर्ट बोल रहा हूं. नहीं आएगा वो नहीं आएगा, उस पर टेंशन लेने की जरूरत नहीं है, ठीक है. फिर भी मैं आप लोगों को करवा दूंगा, टेंशन मत लो. B if I will discuss, B if we will discuss in this question, sir, it is written the ones complement. So we are converting to the equivalent decimal. So convert 1, 1, 0, 0, 1, 0, 0, 0. 1, 2, 4, 8, 16. 16 plus 3. So 19. So it will become minus 19 actually. 1, 2, 4, 8, 16. 16 plus 3. Yes, minus 19. Now in the question they are talking about minus A, minus B. And they are talking about in the 2's complement format, no issues. Minus A, minus B. So I can say that minus A is written like minus 86, minus B, minus 19. So it's called minus 86 plus 19. So minus 86 plus 19, what should be the value we are getting, everyone? 10 चला गया तो 76, 6 चला गया तो 70. अरे यार 7, right, minus 67. So this will become minus 67, right? Hope you guys understood. Floating point भी कर, हाँ floating point अभी करवा दूंगा, कोई दिक्कत नहीं. Floating point if you required, I will cover it, don't worry. So this is a minus 67. Now we can say that this is a minus 67. How we can do it, everyone? Minus 67, so we can convert into the equivalent decimal for minus 67. अब कैसे कन्वर्ट करोगे थोड़ा सा ध्यान से समझिएगा. Now minus 67 we have to write into the 2's complement. So first we have to write the plus 67. So we can say that this is 62, 0, 0, 0, 62, 32, 16, 8, 64, 8. This is called 67, 64 plus 3. 1, 2, 4, 8, 16. Oh, 1, 2, 4, 8, 16, 32. This is called 67. 60, we can say that plus 67. But this is a 67 into the, you can say that binary. So if you want to write into the 2's complement, move into this direction, do not change until you will receive the first time one. Now complement it. So this is called minus 67. This is in the answer. So in the binary, we can say that 1, 0, 4 times 1, double, 1, 0, 4 times 1, 0, 1, 1, 0, 1, 2, 3, 4, 4 times 1, 0, 1. B is the correct answer to this question. Right? It's minus 67 in 2's complement. This is a plus 67. So if we take the 2's complement of it, it will become minus 67. This is the one method by which you can solve this question. There is some second method also, right, everyone? Method 2. So that you can understand in very much of detail. Method 2 of this particular question, everyone try to understand. A is given like 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. कितनी बार 0, 1 है भाई? 1, 0. Right? Okay, A is given. So this is given on that, and now if you want to write the minus A, they are talking about the minus A minus B. So minus A if given, if suppose this is in the signed also the same, if it is even the signed form then also same. If it is given in the ones complement, then also, and the binary also we can write the same value. Now if you want to write minus a into the 2's complement format, so take the plus, right, and then 2's complement. So this is a plus and 2's complement. So move into this direction, 0, 1, and now change it. This is called minus a. Now you have to find out minus b into the 2's complement. This is minus a in 2's complement. It is given signed number, so directly if you take the number 2's complement, directly you will get the minus 2. Now everyone try to understand. This is b into the, b is given, कितनी बार 1 है भाई b के, स्लाइडर कहाँ गया, 11101 और 11101 100. कुछ गलत हुआ है, 11101 1. This is given into 1's complement format. Alright. Now you have to find out into the 2's complement format. Alright. So everyone, whether it is a b, set this is called b only, and it is a 1's complement. So we can find the first 2's complement of this number. How we are going to find the 2's complement? If you'll add 1, 0, 1, 1, 0, 1, 1, 1. This is called b in 2's complement. It is given b in 2's complement, but in the question they talk about minus b is required. Then only the addition is required. So minus b in 2's complement means we have to take the 2's complement of this. So if we take the 2's complement, do not move, and now change it. So this will become minus b into 2's complement. So minus b in 2's complement, 0, 0, 0, 1, 0, 0, 1, 1. And now add it. So answer, this is also 2's complement, this is also in the 2's complement. Let me write minus b in 2's complement. So answer also you are getting into the 2's complement only, right? So if you'll solve this question, everyone, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 0 or 1. Same answer we are getting. Directly we are getting the same answer in 2's complement. Look at here, the B option is there. Understood everyone? Write down yes or no. So whether you can solve the method 2 or you can solve the method 1, it's your choice. So in the method 2, what we have done, we have calculated the minus a into 2's complement, minus b into 2's complement, then addition we have performed. In the method 1, what we have solved, this one we have converted into decimal, this one we have converted into decimal, then we have calculated minus a minus b, and then whatever the result we are getting, we have converted into the decimal, that's into the 2's complement format. That's the meaning of this. So hope everybody knows about how we are going to do it, right? Everyone write down yes or no. अगर इतनी चीजें क्लियर हो गई, बहुत सारे क्वेश्चन इस स्लाइड के अंदर आपको सॉल्व करना है. अर्थमेटिक ऑपरेशंस में कर दिया, ओवरफ्लो बता दिया, सारी चीजें हमने इधर देख लिया, ठीक है, एडिशन सब्ट्रैक्शन का, ठीक है. Overflow condition also you can understand here. Look at here the one more example if I will consider. In the A0101 is given, it is a 2-bit complement form में दे रखा है. B is also given. If you observe, it is given in the 2's complement format. So this is still it is a plus 5. So we can say that this is called plus 5. This is called plus 5. So if we add this number, so it will become nothing. It is just a 10 you can get. Plus 5 plus 5. So answer you are getting into the 10. And 10 you can observe plus 5 plus 5. So this is out of the range. If it is out of the range is given, we can say that definitely the overflow is going to occur. Right? So we can say that because 5 the 4-bit, we can write from minus 7 in the 2's complement, from minus 8 to plus 7 we can use. But the result we are getting the plus 7. So out of the range. So definitely the overflow is occurred. So we can say that it is A, it is B. Here the overflow occurred because minus 8 to plus 7 hota hai. And here if you observe, this is called plus 5, so we are getting plus 10. So overflow occur. Overflow occur. Now you can observe there is a one more example. If A is given and B is given, if you will add it +5, इसको 0 1 1 कर लूँ क्या? सो ये तो रेंज में यार, इसको भी सॉल्व कर लेते हैं। मान लीजिए मैंने क्वेश्चन ऐसा दिया 0 1. नाउ इफ आई एम टॉकिंग अबाउट, एवरीवन ट्राई टू अंडरस्टैंड 0 1 0 1 and it is called 0 0 1 1. So if we'll discuss about 0 1 0 1 and 0 0 1 1, if we'll add it, it will become 1 1 0 1 1 0 1. So it will become 1 1 again 0. It will become again 1 1 1 0 and then 1. So answer we are getting 1 0 0. So 1 0 0 we are getting. So this is if you want to find out, okay, this number is written in the 2's complement format. So this is called nothing. It is just a -8. So whether the -8, everyone try to understand. नहीं रुको एक बार. 1 2 4 हाँ यही हो ना. हाँ this is. Now you can feel both are basically in the same sign is given. Here the sign is changed. So definitely we can say the overflow occurred. One thing more you can understand. If from here whatever the carry is there and whatever the carry is generated from this. So this is called C in and this is called C out. So if you're XORing the C in and C out, and if XORing of C in and C out, if you are getting 1, it means that definitely the overflow is going to occur, my dear friend. So here you are getting C in is called 1 and C out we are getting 0. So 1 XOR, it is 0, right? XORing there. So 1 XOR 0 C out. Oh, you too. 1 XOR 0, so we are getting 1. So definitely we can say that overflow is occurred. और वैसे भी आप देखोगे, this is A is called 5, B is called 3. So 5 plus 3 that is called 8, whereas the range is from -8 to +7. So the range, this +8 is out of the range is basically defined by the 4 bit. For the 4 bit. So definitely result required more bit to store. So definitely the overflow is going to be occurred, right? So ऐसे और भी बहुत सारे example हैं. You can take. Already we have discussed, okay, कि for the overflow if the C in XOR C out, right? If we'll XOR C in means what? Suppose A3, A2, A1, A0 we are doing. B3, B2, B1 and B0 if we'll do. If whatever the result from A to here, whatever the carry will generated, that is called C in. And from here, whatever the carry generated, final carry, that is called C out. It will XOR these two things. And if 0 occurred, means no overflow occurred. And if 1 is there, it means overflow occurred. So by this also you can observe whether the overflow is going to occur or not. So sign bit. And one more thing is there. Suppose A having the sign bit X, B having the sign bit Y, and Z having the sign bit that is called Z, right? Result having the sign bit Z. So if both are basically positive, then result also must be positive. Both are negative, then must be the negative. So if X is 0, Y is 0, then Z must be 0 for the positive. But if we are getting 1, we can say that the overflow occurs. Second case, if X is 1, Y is 1, and here the Z is equal to 0, then also we can say that overflow is going to be occurred. So we can say that X0 means X bar, Y bar, Z plus X, Y and Z bar. That is the overflow condition is happened. So we can say that ये दो बार में टूटा हुआ है, right? X bar, Y bar, Z is going to be happened, and the second X, Y, Z bar. That X, Y, Z all are basically the sign bit. That also the overflow occurred. This question already came into the exam. ये भी एक एग्जाम के अंदर ऑलरेडी आया हुआ है कि भाई जब दो पॉजिटिव नंबर को जोड़ोगे तो रिजल्ट पॉजिटिव होना चाहिए. नेगेटिव आया, ओवरफ्लो है. दो नेगेटिव नंबर को जोड़ोगे पॉजिटिव आया, ओवरफ्लो है. तो जीरो का मतलब क्या? हम एक्स बार, वाई बार और जेड प्लस एक्स, वाई और जेड बार और फ्लो कर. यस, करेक्ट. सो इफ यू हैव अंडरस्टूड दिस पॉइंट, लेट्स मूव इनटू द नेक्स्ट. तो हमने बहुत सारी चीजें इधर डिस्कशन किया है. नाउ फ्लोटिंग पॉइंट रिप्रेजेंटेशन इज देयर, IEEE, बट इसको मैं थोड़ा सा बाद में लूंगा फ्लोटिंग पॉइंट रिप्रेजेंटेशन को, क्योंकि ये CO में भी कवर हो जाएगा.